Alright, so P3. Instead of that one. Recording again. Alrighty, so do I have the ability right now? No, it doesn't want to let me check. Fucking damn bastards. So, let's go upload this to my Google Drive as well. The past one. I was recording a little earlier, so 20. Let's see here, that's the P2. That'll take a while to upload. So there we go. Alright, now we have this one. This one is the December 7th.
Alright, so it looks like it's working.
You bastard. Alright, so and then we'll make this a video. Right, so wallpapers. This wallpaper, open. Oh shit, I was supposed to fucking, yeah. Stream today, and I did not stream today, so that's a thing, you know. Well, whatever. Alright, so should help life extension and cancers. Check out YouTube. I don't give a shit what the hell you want. Get the fuck out of here, you bastard. Jesus fucking Christ. Anyways, so check out. So let's see here. Please check out my video on other concepts. There we go. And that should all be now ready to go. One notification. Alright, so that's done. Content, I suppose we could stream now. Do you want to? No, I'm pretty tired. I ate. I need to go put that away. Uploaded one file. How the fuck did I upload that file already? Whoa, dude. How big was that? That was like a 5-hour file. There's no way I uploaded that file already. Seriously? Seriously? How fucking large are you? Let me see that information, you bastard. Details. No, I don't want. Okay, 6.5 megabytes. No. No fucking way. There's no way. Is it what's the actual? No. 5 fucking hours. No. This is 418 megabits. Yeah. No. No, I'm not believing that. There it is. There's the. Oh, it's that one. Shit. Okay, so that's what that is. And what am I recording now? P3. God damn it. There's P2 and I forgot to fucking. Okay. I know why. Named it wrong. That's what that is. Well, you know, I'll keep it in there. Fuck it. It was this one. It's like, there's no way that's uploaded already. I don't have good internet at all. There's no fucking way. No fucking way at all. Alright. Let's get the other one done faster. Okay. So. Oh, fuck. Christ, wait, whoops. Let's make sure my internet's actually on and not my fucking mobile data here. Okay. So, FFmpeg. Chromebook installation guide. I don't want to edit. I don't care about to edit. You fucker. But this thing's like, oh, you can totally do this. Just install this fucking thing on your Chromebook. First install FFmpeg and Node.js runtime. Sure, yeah, no. Let me just fucking install that. Runtime, from my Chromebook. It doesn't fucking work. Annoyed all the time. For most users, sure. Thanks. Your GUI needs work, you fucking idiot. Fucking assholes. I'm super cool. I like letters and numbers in a fucking row. I don't like GUIs. That's for artists. What the fuck is the programming world anymore? Want another special shot? Yeah, I was thinking about it actually. Go a little lighter. And the bean, it's probably at the place, I don't know. Can go lighter. I mean, 12, 13? What are we looking for? Like, honestly, it's what it's about. I don't know. Like doing anyways. It's like, just do this thing to get Twitch Go Chrome extension for your Chromebook. Fucking just be simple about it. And I'm like, okay, but you didn't really give me any ability to fucking know how to do this. Like, at all. What the fuck? Install Chrome Crouton, apparently. OBS, which is now work directly with Chromebooks and requires Crouton. Your system will become stable as a result. What the fuck is Crouton? Let's get rid of that whole thing that I just did. Let's look at Crouton. Crouton. By the way, my favorite part of a salad back in the day when I was a kid. Hated dealing with Chromium Crout environment. Oh, joy GitHub. Programming world's just full of people that love to just do this thing. Or they're like, you know what? I'm super special. And everything about me is going to go right there in my language. My personality, the GUI, everything. And no one will be anywhere similar, but we can all work together except for I don't really want you to. How did you do that? Oh my god, this is bullshit. I'm terrible. It's kind of a thing. So this... I said, take me to the file. It does not take me to the file. Did not take me to any files. I didn't get a file, GitHub. I have a readme, a makefile. I'm going down here to this whole thing. It's like there's a Crouton clip, Crouton cycle, Crouton find, and a CL, Crouton notify. Or is it just the file in total? Or where's the fucking thing I can download? Is it this tiny fucking link for Google? No. Where do I look for the file to download? GitHub, please. GitHub. GitHub, you darn bastards, GitHub. I swear you don't care at all about your users and you just want to look cool and basically exclude anyone that might not fucking know something. No, it seems like it though. Maybe I'm wrong. Maybe you do want a lot of people. They just need to pass the test to get into the club, to learn how to look, scan, very hard to scan, very similar looking everything. No color coding, no buttons. What is your UI design? Who's your website designer? Just so annoyed sometimes with the GitHub. That's why I was having an issue with it. Steps to install Crouton have changed. Cool. Limit 1 gratitude. Fucking I don't care. It is a Croot. Allowing application rid of this fucking don't care. You can run Tux Racer. Just give me a fucking step-by-step There's so extra about fucking directions. What the hell is with this? It's like, hey, this is what you put in first. Then you do this. Hey, monkey brain, then this, and then run it! It's like, thank you, I don't want to complicate it. I don't give a shit about your bullshit. Just give it to me. People never fucking understand my anger sometimes. To get a crouton extension? Why? What the thing is this target is much more oh fucking okay, fine. Fine, I'll do that. What the hell with the stupid where's the Why is it so long for all this bullshit? Who gives a shit? I don't care about any of this bullshit. Why the fuck do I need to care? Directly access files, but it can't access your hardware device, including blah 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 blah. Fucking okay, Tux Racer. So I have to go and install Tux Racer first, alongside of a Crouton extension. Because sure, to use Crouton, you have the instant release. Download it, pop open a shell, Control Alt T, type shut fucking. Sure, I don't mind. You know, like just but like. Where's the thing I have to download? I think you just clicked it. That's an app extension. And the link for Tux Racer. Oh, it's just saying, oh, but hey, oh, it's sarcasm. It's like, it's a joke, but you could do that. And say, okay, fine, whatever. This is not lending itself to appropriate scanning. Catini. Yes, the cell is to be broken down. So read what it means before you say no, idiot. You're not anything that knows about it. This is not lending itself to the cell division. I'm like, it's exactly the point. That's what I'm looking to do. I'm not trying to keep it going. I'm literally like, fuck off, no, die. Get rid of that stupid stuff that stops your DNA from working. Repair DNA, repair membrane, Bye. Fuck off. Hate these cunts. Don't know things about anything. You know, it took me like 4 hours to research how to do that. I don't trust anything, but actually speaking, that works. Smart people with creative engineering to know, hey, why does it need to repair? Why does it need to break it down to make sure it repairs appropriately and continues functioning like it should? Basically, this is going to go right up in there and get all the way up into the fucking DNA. Really hurt it. And then it's going to fucking repair itself. Should still be a little bit of the membrane if it gets to it fast enough. Yeah. And some of it, it'll just eat it and then whatever, who gives a shit? Well, it should still stay where it's at, so it should repair eventually. Well, yeah, it has the fucking proteins and everything else for it to do it. Just in the blood now. Just constantly. Yeah, because you take the complexes. So it should repair. Yeah, it should repair. But it needs all the stuff to repair it, which it should have. Vitamins, minerals. Yeah, all that, I guess. Okay, whatever. What do I know? Well, it needs other things. Yeah, sure, it probably does. I don't care. That's your guys' fucking deal. What? No, I'm just giving you something that basically stops something. Right, because... Right, it was as a result of the thing that you were talking about. Yes, it's like, this is how they would most likely be doing that. In some cockamamie scheme to extend life. And repair off of, like, super soldier fucking damage kind of shit. Which... It doesn't take much more to basically make a cell form around it, no. And it has everything else to really do it. It doesn't have to eat. It's not going to eat everything. Will it? I mean, it depends on how far along it gets to it. And then it notices, yeah. So it eats some of the cells. Most of them are going to be fine. You have no clue. No. I don't really care. I know that's such a bad thing to say, but like, I don't really care. I know it's like good in theory, would totally work in a test lab. You'd definitely be able to use it on a rat before you do anything else, because they use the same fucking markers and everything. You can absolutely experiment and see how well it actually performs before you try it on yourself. That's the whole reason why I gave it to them. It's like, here's a basic. Try. I got 4 hours in, and I'm like, basically that's probably what they would try and do. Versus mine, which is like, I'm going to change what is effectively what our immune systems target. Yeah. Really, and then put on new markers or cell markers for their waste products and shit. There should be like an increase of this or that, stuff like that. Which now it's just looking at proteins and everything else. And then I get the right right names. Now I have the right names. That's all that means. It's like, oh, it seems so stupid. But now I have the right name. Oh, it's so smart. Oh my god, yay, oh my god. It's like, it sounds so fucking impossibly dumb. Why would that even be a thing? Actually, you know what? Now that you know a little, okay, so, but basically the concept would be feasible. Ahead of the curve, Shade. It's like he already knew how you were gonna act. Well, boom! Here you go, you fucking overreactive, preachy git, dumb bitch, having dumbass. You don't know what that reference is. Get dumb, having bitch. It's a reference to something. It doesn't matter. It just means like you're getting dumber by the second, having bitch. You know, like it's a drug. You're getting dumber by the second you having bitch. You know, anyways. In reality, it's like, no. No, if anything, it just was really fucking simple to figure out how to fucking basic bitch this. Yeah. So, how would you do it, like, if it happened to overrun a cell? I mean, the cell's mostly always going to fucking repair, but there's a certain point where the repair can't be going on. That's why you take a flood of the complexes and the enzymes. Right, yeah. It's like, no matter what, like, it would be impossible to maintain. So you have to constantly take complexes and enzyme complexes. Like, protein and enzyme complexes up the wazoo. You'd always have to be on it. Really. But there's a reason why it doesn't last for very long. Right, because just because it learned, it didn't mean that it will eventually, because it'll start attacking your fucking immune system, right? Yeah, because it starts to die too. So the immune system attacks itself and it gets rid of itself until there's very little, and it dies of old age anyways, and it can't attack itself. So, like the one few cells can't just wrap on itself. So they have to be redone. So it's always temporary. Once a quarter, taking pills all the time. Yeah, just like I talked about for the CIA, whatever fucking acronym thing is. Yeah. So it works brilliantly, and in fact, and it's temporary, in effect, and you can stop it after a certain point. Absolutely, yeah. God. And you're like, I don't want to do that. No, I don't actually at all. No, absolutely not. It's garbage. An utter lunatic would use this as it's feasible and helping. As a concept, I guess it would help. You could take it for 5 years and you would see a reduction in some of the issues you'd probably end up having. You know, that's about it. It's basically irrelevant. It's like, oh, it's a nice, It's like you saw It's a good fucking analogy. Like you kind of like lightly tapped a beach ball or something, and it kind of blew over. You know, it's just whoosh. You know, it's like whatever. It moved a little, so it helped a little. It's not that much. You know, didn't do much. But it's like, there's a reason why I'm like, you know what? It wouldn't be that hard to structure an mRNA vaccination like Moderna has. Really? No. Really? Yeah, because our lymph nodes, which produce those cells, I'm pretty sure. Because I remembered what the hell they're called finally. They filter substances. Is a part of your immune system. Lymph vessels, nose, veins collect to carry blood. These vessels carry a fluid called lymph. What creates the fucking immune system? What creates immune cells? It's bone marrow. Ow. Show. What? Nothing. I'd do it though. You know what? You don't want to hear me say that, but I would absolutely do it. I wouldn't even slow down. I'd take the fucking bone marrow shot. Ow. Yeah. Hey, you, bone marrow. I'm so glad I'm on fucking things that make this hurt a lot less. I know, right? Yeah. There we go. Now we're doing this one. Let's create one of these fuckers. Upload a video. Let's select files. Let's select multiple files. Why the fuck not? Are you sure? No. It's the opposite. I prefer to put all three of these together. I am aware I am not going to. Can I though? I might be able to upload 3 at once. Maybe. I'm uploading 1 right now. Well, that goes well. That creates me. So the bone marrow, hematopoietic stem cells. Hematopoietic. What the fuck? Why do they just HP cells? They're HP stem cells. That's what they are. They're the HP stem cells. That's all I give a shit about. These cells have a potential to develop and mature into different cells of the immune system. Okay. So that's it, huh? No wonder why it's like, oh, I need an injection, do I? That's what they were angry about. Yeah. Fuck. It's like I could do it, but it's like, ow! Do you know what you're doing over there to yourself? Yes! Yes, it's fine! Kunk! Oh! Oh! Fuck! Kunk! My arm hurty! That's what I imagine that would be like. Yeah. I'd probably not do that though. Although I might be able to do something like that. I mean, there's got to be something that makes it so that way they get out. What? Yeah, I mean, the immune cells have to come out of the damn bone marrow. Okay, let's look into that. How do the immune cells leave bone marrow? That's a fair point, yeah. Where are B cells? So they move towards the central region, or they exit through a dense or capillaries. So what did it enters? It enters through the cap. I mean, the capillaries have to pass by. They can't just like, yo, I'm here and then I left somehow. There needs to be a flow. How does blood enter the bone marrow? How does blood enter bone marrow? Third, an endostele cavity by nutrient arteries, then flows through sinusoids for exiting various numerous small vessels that ramify through the cortex. What's the indus cavity? Let's look this up. Membrane lining, inner surface of the bony wall is identified as a living membrane and aligns so let's see here. Delivered blood supplies delivered to that by nutrient arteries. So nutrient artery, let's search that one first. There you go, search that. There we are, nutrient arteries for bones. Nutrient arteries for bone. It's essential. So I could just inject this in. Of course. I just need to make it small enough to make it. That's all? That's all I have to do. Yeah, then flows through the meristanoids before. Okay, so that's it? Why do we have bone fucking marrow injections of any kind then? Then I wouldn't need to do that. Right? Yeah, I wouldn't. Why the fuck? Yeah, no, I wouldn't do that. If I don't need to do that, then I wouldn't do that. So meristanoids. Let's look up you fucks. Bone meristanoids, many are swimming by between the bloodstream. So it's a HP compartment. Hemopoietic. Ugh. It does sound poetic, doesn't it? But thank you for the help. So does anything ever get to them? Shit. Can you change... Wait. No, because it's immune system, and it just puts out... Right. Wouldn't be able to make it with an immune system. I'd have to make it with an mRNA. Does RNA or mRNA? mRNA. No, you bastard. mRNA effect. Is it effect or affect? I think it's effect. Effect. Let's copy that fucker and V. Hemopoietic. No, it was effect with an A, of course. You were wrong. You were fucking me over. The person that says effect, it wasn't me. I just trusted them. Alright, so let's see here. Regulate the amaranth, emphasizing their role in malignancy. So there are proteins in that fucker. Huh. Really? Yeah. It says to decrease in self-renewal, aether differential protein synthesis. Huh. I do need to think, actually. Yeah. Alright. Well, so we can affect these cells. Yeah. Yeah, no, we could affect these cells. And I want to affect them in a really particular way by changing their DNA with a Cas9 installation, change their DNA. But it's like, do I do a DNA change or do I do a protein structure change? It's like, I know DNA can change its protein expression and everything else, but we need to change the protein We need to change the immune system. We need to change it so that way it grows something better. Yeah. Not to mention, it's like you're wanting to basically change him back. Let me look at that real quick, actually. DNA expression for change to stem cell. Epigenetic renewation, stem cell differentiation, progression of stem cell differentiation, progeny is long-lasting change in genes. What causes a cell to turn to a stem cell then? Thanks. You fucker! You're not telling me. You bastard. I don't care about transplantation. Motherfuckers! Why? They don't tell. It would not appear. What is this? There has to be obvious things that turn them back into cells that are the stem variety. There's no way there isn't. Ow! Jesus, fuck it, Furby. Jeez, fuck, ow. Fuck. Cell to stem cell process. Body or laboratory stem cells divide to form more cells called daughter fucking. Specialized cells differentiation with more specific function. So they're already a stem cell. Apparently, when they're going through their G2 to M or S to M stage. That's not what it said. Interphase, prophase, M phase, telophase. I don't give a fuck, you stupid cunts. Tell me what the hell this is before you get me more angry about this. Because apparently I couldn't even describe it to the PhDs because they don't even know. Some stem cells in your bone marrow. That's stupid. It shouldn't just be that. Right. Any cell can turn into a stem cell. We know that. Stupid cunt motherfuckers. It's just giving me transplants. I don't give a shit about your transplant. Let's breathe. How to turn a cell into a stem cell. Because apparently you can't fucking grasp what I'm searching for. You absolute not. In any way other than a cunt at this point. So they use viruses to insert 4 genes: SOX2, OCT4, KLF4, and CYMC to these cells. We program cells to introduce programs from cells to generate huge many same field. So it's a DNA express. Fucking, I hate this shit. They make things sound complicated when they're not. It's like, look, so it's these things that do that. It doesn't sound at all like that's exactly what that is. It sounds like you have 4 fucking options here that you all need to change. So, like, there's nothing saying I can't specifically target the bone marrow thing. What is it? Marrow centroids. How does it say? I'm an RNA. So, let's review, regulate, emphasizing the role, whatever the fuck that is. So, loss, associated, decrease, HC. Null ithroid protein, unique. So competition. So I need to know about those cells. So I basically would do a very similar version to like, hey, that cell, does it live forever? Is it like more like a permanent cell? So its ability, but it creates No, you're telling me this fucker creates my immune cells. So they can be immune. Yes, to doing that. I get it, but nice one. It's a good one, yeah. Thanks for the levity, man. I needed it. Are you thinking back to the drawing board for a second? Really? Yeah, because I want to be able to like, because of course they need nutrients, and they're gonna express RNA changes, like they have to. And during their differentiation cycle, they have to fucking turn into something, and something has to tell them that differentiation cycle. Right now, they're just stem cells. As far as I can, so let me just say, so this hemolytic, let's search that. Hemopoietic. Thank you. Stem cells for immune system. Turn to immune cells. Triple immunity are responsible to the use of blood cells. Hey, you fucker. Responsibility to all blood cells and immune cells. Okay. Yeah. No, it's angering a lot of people. Really, it's like I search one thing, it says something else. I'm getting pissed off. Yeah, and so it's like, all right, so HSCs are responsible for the blood and immune cells. So, what would be the differentiation factor proteins? Protein factors for stem cells. Key transcription factors for differentiation. So we want to be able to change that, though. That's true. I'm actually looking for something else. Really, yeah, I want to grow something here. So I need to break it down, enter it, change the DNA, and basically make that DNA have that written structure to have these changes in its function as an immune cell. So I'm basically going to use like a similar version to the calcium binding protein, calcium binding protein, to basically create this like, hey, you go over there and hurt that thing. What? Yeah. Why the fuck wouldn't I? I mean, can immune cells get into them? Can immune cells Can immune cells get into bone marrow? They are observed to be in the bone marrow. So we start with what they have. We go, fuck you, stem cell. Pound. I guess you're done. Hey, that DNA sure looks like it's fucking not right. Hey, maybe you need this DNA instead, you fucking tool. Because it says, yo, I'm Cass. 9. Not like those cool guys. Like 10 or 9 or something. I don't know who I am anymore. What am I? I broke off something. I'm something else now. It all happened that fast. And it all changed. And I was different forevermore. No longer Cass 9. Shit. That's a good joke for me. Yeah. Alright, so let's see here. So we're gonna break in, we're gonna shove the Cas9 into it. We need to fucking basically just Cas9 it, right? No, we can't do that very easily. We need to break in. But that stem cell needs to repair itself. Because it's still gonna have those proteins and everything else. Why would you need it to break in? Because I need it for sure to be repaired. The Cas9 isn't going to target anything without a very specific marker there. Which, by the way, you're going to have all the markers for all the things going everywhere. Cas9 doesn't know what to target without an ability, and it certainly doesn't know how to specifically differentiate cells right now. Really? Yeah, no, it needs to learn how to do that. Endure! The enzymes. No, I don't want to do enzymes. Enzymes are lame, and they won't work very well. How to have Cas9 target specific cells. CRISPR-Cas9 assess the relevance in off-target sites. Can CRISPR target, in contrast, Cas9 uses a single endonuclease Cas9 to RNA-dependent manner. Or a specific gene. I don't care about the genes. I want a cell target, motherfucker. Alright, I'll help them with something here. Because what's going to be released upon the cell going, oh, fucking God, I got hit. Fucking bastard. Oh my God. It's one hell of a wallop. What's inside of a cell? That's the fucking hematopoietic cell. Hemopoietic. I don't know why. So many fucking problems with this word because I just don't really like the word for some reason. I don't know, really. Don't care, tell me. Red blood. You. Tell me what you're made out of. We're going to Wikipedia? Great. Okay, then, they sometimes have good information. It's true. We should check it out. What? I just read something I hate. They're like, we don't really know how to differentiate them, but like we think Lin minus and like this cell surface marker CD34 and like several positive cell surface markers which are in the lineage markers used to differentiate. I'm now pissed with you right now. You have no idea. You don't have more? So let me look this up. Lineage cell markers. So cell surface mRNAs, yeah, and internal proteins. Okay, so that's all those are, and then several positive cell surface markers. Cell surface markers again. So cell surface markers for fucking stupid hemopoietic cells. Hematopoietic. SCA-1, CD27, CD34, CD38, CD43, CD48, CD117, CD150. We're going to lose those. We're going to use the shit out of those motherfuckers as some lineage markers, my man. Do stem cells have lineage markers? Whether you're working, oh, you fucker, just tell me. Give me what I want now! Lineage. Hematopoietic. Is it etic? Spell that right? Maybe. Let's see. Hematopoietic. Fucking. Thank you, though. You're helping. Sustain the blood and immune systems through a complex lineage commitment process. Fucking. Who cares about what the process is? Tell me what they are. I don't. Google's not being friendly. Sergey, you bastard. I knew you didn't want to get rid of your fucking Parkinson's, which is a bad macabre joke. Such a bad macabre joke. That's a bad joke. He's like, nah, I don't care. It's like, what? Dude. Okay, to each their own, I guess. Okay, so myeloid. No, I mean we don't have to attack those cells, technically speaking. Really, yeah, no. If I can just learn what the hell they are, that's what I'm trying to do. Is to change my current approach. Really? Yeah, because then I'm like Cas9 CRISPR. Just inject, bitch. You fucking what? Where's those multitudes? Yeah, give me all of those fucking syringes. Captain America time. Remember the scene? You remember the scene. How are those cells created, by the way? Can we ramp up production? We might be able to. No, hey, I didn't want to exit out of that. Oops, misclicked indeed. Alright. How are hematopoietic stem cells created? Because that's what we're looking for. Subset of embryonic endothelial cells that possess homeogenic potential. Because we could always hit them, but it wouldn't work very well. We need to get to the source of these things. At the time when the clusters are pure in the ventral wall. So we need to hit these fuckers. Subset of embryonic endothelial cells. Embryonic endothelial cells. Location. Differentiation factors for stem cells. Don't give a fuck about any of this no more. Bye. You all were basically worthless, almost. But you got me there. And now I got lineage and embryonic endothelial cells. Most areas the most contained called angioblasts, which formed in primitive vascular network. Subsidies spreading angiogenesis, branching, remodeling to small and large vessels. Neat. Abstract embryonic stages. Mesoderm, specific extra embryonic and embryonic regions through a process called vasculogenesis. You're not getting me anywhere. From ingressing mesoderm. It is derived so the endothelium is derived from ingressing mesoderm. Mesoderm, epiblast and hypoblast induce mesoderm formation. Then induce a subset of mesoderm hemangioblasts. These hemangioblasts will swell and form clusters. Okay. Let's get to the mesoderm first. Mesoderm. The middle layer of the three germ layers that develop during gastrulation in the very early embryo of most animals. The ectoderm, the inner layers, the endoderm, mesoderm, tissues derived from. So, what is the mesoderm and what is its function? It's responsible for formation a number of critical structures and organs. Embryo with developing, including skeletal. So, give me a second here. Ow, Furby, you are scratching the shit out of me, honestly. I get that you want, the whole scratchy scratch, but still. Would you have killed cancer with this? Well, yeah. Honestly. They still need to intake calcium. And if anything, it can restore the cell's function. What? Yeah, no. If it's like, oh, I needed to intake calcium. Then it's like, oh, well, this is attached to that, so go attack it, immune system. Go repair yourself. Or kill it, depending on how fast it did it. Yeah. And how much. Because it's like, oh, yeah, no, I killed the fuck out of you. Well, I'm not dead, really. I still have all this stuff around me. Nah, but I can't attack you anymore. You don't have anything attached. Like, there's no calcium, no whatever. Like, what is that over there? RB? Is that RB protein? Fucking bitch. You were hiding on me. You're hiding out, aren't you? You little fucker. Alright. Let that be a lesson to you. I have to leave. Oh! Help me! Wee woo Bills! Where are you? Oh, thank you so much. Proteins farm around me. Give me comfort and shielding from the not so nice nature of it all. You want a fucking goddamn stupid ass bitch membrane or not? I'm trying, man. Yeah, I know. Shit. I know, it's the inhibitory process. Well, we're aware of that part. Wait, why would you know that? Just because I freed the DNA doesn't mean the DNA didn't do some shit to split itself. So it's really just needing to, like, reconnect. That's why you got the fucking other complexes. Spiel, joke, run aside. It's funny as it is. I'm actually worried about something. Really? Oh, yeah, no, I'm actually worried. Like, it would work. Pretty well, actually. If I'm being honest, yeah. But it also comes with many side effects, for sure. Yeah. What kind of other side effects? Well, for one thing, there's a reason why you want it to be temporary. For sure, you don't want it to last for too long. Your immune system would become a problem. Really, it'd attack anything the moment it was trying to divide. Your permanent cells would be the only things that weren't going to be attacked. Oh, yeah, and getting into transcription reduction process doesn't mean it completely. That's why it has to repair. Right, and then it has to repair everything else. Right. Well, yes, because you have the right. So what's the problem? It doesn't really want to do it when there's no damn membrane to begin with. And so it needs to form one. It's just like a bunch of other shit, right? Yeah. Let me look at this real quick. What makes a cell form a membrane? It's a property of lipids. clear common structural and bilayers of phospholipids with associated proteins. Well, we have the proteins. Huh. Yeah, no, it would try and create a fucking membrane regardless if it has that much proteins and enzymes. True. Yeah, I'm pretty sure. Pretty sure. I mean, that's all lab tests. Really? Yeah. Yeah, no, I mean, I put it on a petri dish and go with a pipette. And it's like, did it form a membrane? And it's like, yeah. Uh-oh. It might actually work. Just gotta get glycerophospholipids molecules composed, of glycerol, a phosphate group, and 2 fatty acid chains. Ow! Jesus, fuck those claws, Furby. Fuck! Jeez. No, you don't. You need to do all these other fucking things. There's no fucking way in hell that it would only... He says he has those. What's that? I know, right? She's screaming so hard. Okay. Have cell membranes been formed in a lab? Chemist biologist 2015 succeeded in designing and synthesizing artificial comprised of sustaining continual growth just like a living cell. Fucking goddamn bitch. So, forming amphibic compounds. Okay, I don't care. Artificial cell membrane. Which in 2015, and then there's a 2012 one now. So... I need to tweet something. Yeah. Let's tweet. Let's make this happen. Elon Musk, eat your heart out. You might have someone coming up with like a legitimate, actual way to beat some cancer, for the most part, yeah. Because then it's just an mRNA, attachment protein that you just inject into someone at a particular site and then sponge it out in another area, and then it would basically have your immune system attached to that. Eat it! And you do that every so often. And then you'd be like, it's done. Cancer's gone. Alright, so immune system breakage of the cell membrane is usually a bad thing. But if I can make a basic, actually, if anyone can make a basic whoops. Okay, give me these. Where properties of the structure and bilayers are associated so I made a copy. Okay, so I'll do this real quick. A basic support supportive environment with Control V. Environ. Yeah, Viron. Ron. R-O-N. With phospholipids. And those. And what was it called again? You've already forgotten, huh? Yeah, that one's kind of rough, isn't it? It's a lot of things to remember really quickly, really fast that you're doing. Like, legitimately, no one's talking about it, but, like, you should talk about it. Like, you're genuinely, like, creating a whole bunch of shit really quite quickly. Yeah! Shit, alright, so vaccine, mRN, that's what it was, mRN, that's what it was, mRN, and enzyme complexes should help form healthy cell membranes and DNA correct during cell repair. Let's do the Joe thingy again. Yeah. Alright, what was his name again? It's freaking For Love of Science, okay. For LOV of Saints. Anytime you want to catch up, anytime, fucking god, fucking damn it. Fuck. Let's see here. Add Aubrey. You fucker. Keep forgetting it's not a phone. Really? It's a whole thing. Brady Gray. You fucking. About life extension? Yeah, sure. Life extension. No! What? It's the right fucking one. God damn it. I need to get rid of a comma or something. Let's get rid of that comma. Alright, so, which they should have that because you ate the shit out of it. Just around. No, it's not gonna be, well... Huh. No, I don't think it should be around, but you can make it be around because you do have fat. You'd have to create fat. So, like, if you can make glycolytic acid, alpha GPC would basically be that, right? Yeah. What's this alpha GPC again? GPC again. This choline. So close. Let me see that. What the shit? Fuckola. That's. Alright, nothing. Somebody fucking saw that and was kind of weirded out by it. Search this fucker for that. Bye. make them? Are fatty acid diglycerides with a phosphoryl attached to the terminal carbon. You could make them. By cell rent or cell biorent in the brain. Oh, hey. Huh. I know they're in the membranes. Okay, so... Can you buy? Yeah, where would you... Does the body produce... Built body attachment 3 such as 18 carbon linoleic acid, DHA, and many others. Does the body produce them, yes or no? I want a yes or a no. It's so simple. Does it or does it not? I know, they're like, you're fucking autistic. I'm like, keep going. Keep trying. Make yourself feel better later. You know, just keep trying to go after something. You are though. Sure. Because you're someone that can diagnose me. There we go. It doesn't really say, and I'm kind of annoyed. It says this thing is functional to doing something with it, and I'm like, that doesn't tell me that it makes it. It doesn't give me the profile of how it breaks down and is made in our bodies. How does it produce it? The body produce. I'm just going with it does. The attachment. Okay, we know this one. It doesn't matter. Who gives a shit? You fucking suck, you fucking bitch. Medlife.ca, cunt. It's like, yo, here's DHA, some 18 carbon linoleic. Fuck off. Some acids and some other shit. Doesn't seem to. It has to. There's no way it makes sense it's not. Otherwise, cell membranes never get made. It has to be being produced in our body somewhere. It's turning our fat in our bodies, the DHA from our fucking bodies with this chemical into the fucking, what is it? This is the PE, whatever the fuck it was called. And then it turns it into glycerophospholipid. It has to be doing that. Why? Because it has mitosis. You have to increase the amount of cell membrane that is there. So it has to make more. It doesn't just stay the same amount. Shit. Let's go with production in the body. Production in the cell. Here we go. Synthesized from glycerol 3-phosphate in a de novo pathway that initially produces phosphatic acid, PA, and then phosphatidic something. Diacetylglycerol, DAG, PA and DAG, or citidine, DAG, CDP, DAG, 1, 2, 3. It's just... So let's just fucking just make a shit ton of that, I guess. I'm gonna fucking tweet that. So... They can't stop themselves. But you are, though. I know they won't stop. They're just so obviously fucking jealous. Like, he has to be autistic. That's the only way he's so smart in, like, anything. And I'm like, no. No, I just don't feel the same way you do. That's what that is, but whatever. Into the pill complex, the protein and enzyme complex. Enzyme complex. Then you create a favorable. Damn it! Just doesn't spell it right. A favorable environment to have cells successfully repair themselves continuously. Well, with consistent injections and pills. Alright, so that should shut them fucking up for a while. Someone liked my thing. Really? Yeah. That's nice of him. They're from Mexico, apparently. Or somewhere, I actually don't know. Shouldn't say they're from Mexico. Sorry. I Kitchen invento. I'm sorry, I'm so terrible with like everything. It seems like these days with like geography and stuff. It's just not my strong suit. Well, there you. That's how you create. Fucking gosh, shit. Ah, it seems like you are smarted again. Outsmarted again. Well, you won't make it so that way the cell membrane starts and forms around the DNA or any of the other structures. So let's use differentiation techniques. Actually. We need to basically create. What was it called again? So where is it? Differentiation. Damn you! Fucking protein factors for stem cells. There it is. Why is it a new fucking? Okay, because I hit both of them. So key transcription factors. So differentiation. So transcription factors. So we need to force transcription factors into the site. At that point, if full membrane breakdown has occurred, possibly. Why? Because it's like, yeah, you see what I'm doing. Like, honestly, because it's like, look. Almost a stem cell. We're literally, honestly, yeah. We're almost a stem cell at that point because it broke and now we have a new cell membrane that's trying to form. And then we also have like a brand new fucking like, what the hell's inside? It's like this DNA doing whatever the fuck this is. I need to make sure that the membranes for the mRNA are forming correctly, all the rest of it. Yeah, I mean, it should do that, truthfully. So it should form. But it's almost a stem cell. It's almost a stem cell. But it's not, though. It's not. Why? Because I'm tired, man. Fucking dealing with some stuff. So, let's see here. What parts make up a cell? There's too many cells, man. Yeah, it's true. Membrane, the nucleus in between the two, the cytoplasm. Integrated arrangement of fibers, hundreds, even thousands, minuscule but distinct structures called organelles. Huh. Basically just breaking down the cell wall and going after the DNA transcription problem. Brute force approach. Let it repair itself. Yeah. I mean, it's not gonna. I mean, if it doesn't kill all of it first, he's right. If it gets to it right time. Endoplasmic origin, cell membrane, cellular tubules. Chromatin, ribosome, smoothing the cell. What you doing? No. But I'm having fun. You can take a lot of damage, though. Yeah, that's kind of one of the reasons why it's like, well, you ate something over here, but then you got all the way into the fucking... what is it fucking called again? The thing with the stupid... God damn it. Exit. Just we'll save it. Fuck it. Why not? Well, yeah. I mean, a little. Yeah, actually. Because you'd want a favorable environment. Wow, those things would get so expensive. Why? They're just... But to me, it's like, well, this doesn't make sense. It's like really stupidly simple to make a large amount of these proteins. And these enzymes. So why is it expensive? Not telling. Ooh, money! That's what it's about. Figure that one out immediately. Phosphate or B. Becomes an active, leading to liberation of E2F proteins, thus inducing expression of genes involving Gs. But instead, we removed that, and we removed these other genes from happening there. Yeah, right, which we don't increase the gene rate expression. Right. Of mutagens. No. Okay, protein pita is second the activity becomes an activity in deliberation E2 proteins of the sun decreasing. Genes involving gene 1 remains inactive and phase positive feedback loop. Expressed accelerating a highly conserved protein family found in yeast. Everybody tries to say it all the time. Necessary amplification factors since we're initiating which we don't want it to do, so they're not going to be there. So let's go scroll down for the S to M, which is G2 to M actually. So profound, blah blah blah, cyclin B, CD, essential for the transition of G2 to M. Subtypes in mammals B through 1 through 3, centrosome associated checkpoint kinase CHK1 phosphorylate CDC25B, which evokes extensive role listing in both G1S and G2M. Progression by D. I don't care. Running the degrades, disappears in the middle. The telophase of mitosis. I need to know what you're doing with the fucking goddamn membrane. And how it is that during this process, you basically make the membrane solid again. It doesn't say. It does. It doesn't, though. What? It's using the fucking CDK4. It's the phosphorylating is what we were talking about with the fuck was it called? The cell membrane stuff. Yeah, the glycerol inserting into the protein enzyme. So the glycerophospholipids. So it just needs to attack those transcription RB genes. trainer, so which eats them. It's gonna eat the shit out of them. It's probably gonna get pretty far in there. It won't kill the entirety of it, will it? Because it's like it's gonna start eliciting cyclin D1 proteins well before it gets to a full G1 cycle. So the start of G1, right? Which I had to look for that one. Regulates early events in the G1 phase. So for nuclears, proliferating cell nuclear antigen PC and A cell division cycles 25 proteins. Geminin, cyclin D, CDK4, CDK6. Right there we go. That's what it says. D, CDK4, CDK6. Subsidiarily. So, but then it says that for sure the D1 is on the outside of the membrane, which you don't want. And then now we're getting rid of the RB proteins. Right. Would we eat it entirely? It's really just going to target what the hell it's being told to target. At least it should. Cyclin materials as for cyclin ED, MCM proteins, essentially initiating DNA. Regulate the completion, all three CD8 function during mitosis, responsible for mitosis. Okay, so cyclin regulates events early, but they're not on the outside of the membrane. No. Close. Yeah. Instead of why the retinoblastoma? Because those should be. Where are they located? RB proteins location. Look at chromosome 13. So. Okay, so we go back. So it makes up a cell. Where are the parts? Where are the genes located in a cell? Okay, so chromosomes and membrane, chromatin, nucleus. Which one? It's a good question. I'll absolutely say that's wrong. I don't give a shit. Tiny called chromosome. I get the chromosome. I know the chromosomes, you fucker. Nucleus. Thank you. Why won't it just... I hate it. I hate it all. Because it's like, I need to know how to attach myself. So and that's what it is. It's like you're getting through the membrane, then you want to get into the nucleus. Which is what I figured it would be. But I had to check. We're not taking down the mitochondria. We're not taking down a lot of the things that you need. You're not just gonna go after certain things. It's gonna spill out by the time it's already starting its G1 process. Those other RB proteins. Yeah, it should. Well, yeah. I mean, bind to the E2F transcription, including transcription during the early G1 phase. Transcription. Some transcription. Let's look up that. Gene expression. Inhibits gene expression. So it's just going to make the cell think it already went through its S. Now it's going to go into a G2 state. It's likely the case. But I don't think so, actually. In fact, that's probably wrong. Like, you don't know what you're saying. I like what you said in a confident manner, but no, it's not that. It's just not straight up true at all. What I'm reading here, the G2 to M needs a particular cysteine B CDK1 complex from a G2 to M, which would mean it didn't happen because we didn't have a elicitation of the, what was it called, ER2, what is this, E2F proteins, liberation, elicitation, yeah sure, liberation, why not, whatever, I don't give a shit, that's what they wrote. Comes inactive, So there's no E2F transcription factors, which those are found to be combined with the RB and then will suppress other transcription factors. No, so shift and then mitogens, ERK dependent activation, gene regulatory, which increases gene expression because of cyclin D to F gene. So E2F gene is no longer bound to those proteins. What would that do again? Inhibiting transcription. So now we're no longer inhibiting transcription, which would mean it immediately starts the process of leading to liberation of those E2F proteins, inducing the expressions of genes involved in the G1 through S transition, including the CMYC, cysteine D1, for actually attacking. So it would keep trying to attack that. Cysteine A, cysteine E, P21, CDK2, CDC2, PNCA, and CDC25C. RB remains inactive during the M phase. It is dephosphorylated by PP1 type phosphatase. So he might have been right there. What? Yeah, that guy that said something in a confident way might have actually been right. Like, just, I mean, sure, there's Syslin D, but that just means it's trying to fucking form a new goddamn cell, larger one. That's all Syslin D1 does, which is what I told it to go after. Yeah. Let me look that up one more time. Syslin D1 does. What does it do? What does. You know, it would really be really, really shitty if someone came up with a cure for cancer and he doesn't know anything. I don't give a shit, you fucking cunt. Tell me what it does to the membrane. It promotes cellular migration and increases cellular migration velocity. Known for its cellular migration of fibroblasts and mammalian cells. Because regularly. Getting growth factor receptors, and downstream factors. I don't want growth factor. In fact, I want it to stay exactly where the hell it is. Huh. It doesn't seem like... Okay, so what causes a cell membrane to grow? Polarized. Cytokinesis. Drive the addition of membrane as to complete cell separation. So it's the polarization, which is what I was planning on going after instead of this Syslin D1, because I thought that that might be the correct thing. And the cat comes in. What signals a cell to grow its membrane? Receptor tyrosine kinases. Huh. Huh. Cell growth, they're called growth factors. Tyrosine kinases. During mitosis. Okay, so that might actually give me something right there. Growth phase G1. See, the thing is that I'm trying to catch it during its growth phase. Yeah. That's high rate senses proteins produced in DNA. I want to know about G1. What causes a G1 phase? You fucking tool. You're just giving me fucking questions. I don't care. I just want to know. I don't know why the hell anyone would not just basically use this instead of a bunch of textbooks and having to answer questions on a test. Okay, so what signals the cell to grow its membrane during mitosis? What protein is on the outside of a cell during its growth G1 phase? It is on the outside of the cell membrane during G1 phase. What phrase is Nigerian? So I'm stopping myself from punching my fucking computer. Okay. Tell me the information I know someone already knows. It's been forever you've been doing this. There's no fucking way you don't know what the protein is on the outside of the cell when it's in the G1 phase. Tell me! G1 phase membrane protein. Tell me, you're a fucking cunt, you can't fucking suck my balls. You're a fucking cunt, you fucking stupid cunty ass scientists. Tell me what I need to know. I don't give a shit about any of this goddamn shit. I already have found out what it is I need to do. Break down the cell wall and basically make it fucking just simply do a simple basic bitch thing called repair itself. That's all I want you to do. Stop fucking around and give me that protein so I can fucking stop the RB synthesis and force it into an M growth stage, or near it anyways, thus causing a cell repair functionality to occur with the correct protein complexes and enzymatic tools to heal it. And glyphospholipids, whatever the fuck things, to basically allow for it to correctly heal. Yeah, that's right. I'm holding you now because I want to actually read this, Furby, and you're annoying me. I'm blowing on you. What are you gonna do about it, huh? Alright. Cat abuse! Get over there. Alright, not what I need. So the higher rate of phospholipid turnover. So coordinating that I don't give a fuck. I don't give a fuck. Tell me what possible proteins might come out on the damn cell membrane so I can have it go nom nom on it. You cunt. You absolute fool of a bitchwad. Why didn't you learn this? Why didn't you fucking give me a basic ass bitch explanation of what's on the membrane during its G1 phase? What's on the cell membrane during G1 phase? You are fucking, I'm gonna murder you. Beard size, protein. What happens to the cell membrane? Cell membrane, G1 phase. Everybody's all excited about what's happening on the inside. I don't give a fuck what's happening on the inside. That means nothing. You are literally stopping my progression. Can't you give me anything? I don't care. I don't care what the gap fit. You fucking suck. Cell membrane activity during. What was it called again? Syslin D1 release. Membrane-associated form of Syslin D1 enhances. Okay, that might be something. So introduction in I don't give a. Membrane. What happens to the membrane? Give me the membrane. It's located in the cytoplasmic membrane. Ooh, is it close enough to be seen when it's feeling out for it? That's a good. What the fuck is this? Cytoplasmic? So let me search that bastard. Alright, because it will break down that membrane and go after it. Of cells. Location. Location. Let's go with location. Fuck it. Between the cell membrane and the nuclear membrane. Of course it is. It must change something, though. No, I just need something else to make sure. What the hell happens to the cell membrane? Because if Syslin D1 is there, then the outside cell membrane has to be affected. It's gonna grow. So it becomes polar? Is it only just becoming polar? Isopolar, whatever it's called, right? Yeah. cell membrane iso what is it called again? Isopolymer, right? Isopolymer, sure. Effect. No, it's effect. Right, this one's effect. Yeah. I didn't mean to keep it then. ISO something. What is an ISO? What is it? What are we ISO? Isotropic. Isotropic. That's what it was. Isotropic. When does the cell membrane become isotropic? Isotropic growth. Okay, so let's just fucking talk about that real quick. Yeah. Alright, unsent tweets. Delete this fucking draft. So, if we can target the isotropic change in the cell membrane during the G1 cycle of our cell growth, then that breaks it down to attack our cysteine D1 protein, which will force it to get further into our cell, then attack the RB 107, 130 proteins to force cell repair to happen before and cell repair instead of mitosis. Should have added the isotropic change on the cell membrane. I wanted to say that in my original trait, which I have uploading in my Google Drive, the progress of this vaccine style cell repair biohack. I changed it because I thought that Syslin D1 would be on the outside of the membrane. Whoops. I didn't write whoops because I didn't have enough freaking characters. Alright. It's not. It's going to be. It's being uploaded right now. I have slow fucking internet, you fucking asshole. Just fucking ass. Why is it paused? Waiting for network? Can you go back up again? What is this? What is this? My network's fine. What? What? I didn't do that. Fuck off. Why is it waiting for the network? Why do it need to wait for the fuck? Oh no, it is. Wait. No. What? No. That's the other one. You're a damn cunt, this fucker. Alright, so upload. I don't know why it's taking so damn long. I don't even have a 1 megabit upload, dude. Why don't you go fuck yourself? Splayed into a rake just multiple times. Just bleed out on that fucking concrete floor, bitch. Let's go do that. Why are you taking so long, man? Why don't you fucking shut the fuck up? I don't have internet like you, Mr. fucking 1 goddamn gigabyte upload fuckface. Fucking rich ass cunt motherfucker. Jesus fuck, lay off me. Fucking damn it. Still, no, yeah, no, I just restart the upload. What do you know? No longer waiting for the fucking stupid network. Whatever. Fucking sure. God damn it. Isotropic protein, yeah. Right, if you can go after the isotropic, then you can go during, and then get into Syslin D1, and then get into RB. Which will definitely force cell repair. It does change the protein structure on the outside, is what it's saying. Right? Early, I'm better mother cell. So, can we? Is that a thing? It's early. It's on the outside. It's just membrane. Like, if I can just get the membrane to get fucked, because it needs to change. Like, obviously the membrane's going to change its structure. It looks different when we, when we look at it. It's got to change its structure. During career, so it is. I'm better. Mother cell grows extrovert growth. It occurs uniformly over cell surface. Which is now going to be the daughter cell because it's going to eat the mother cell's isotropic growth, which should still allow for there to be a cell membrane left during early mitosis. But it will kill it before, because it forces it to start immediately, right? Right. So G2 to M is what we're looking at here. Morphe, blah blah blah. Syslin B transition. Okay, you know what? Let's read this first. We go too far. Growth occurs. Samples of lymphos initial birth growth occurs. Constant exponential growth. Did somebody knock on my door? I don't think so. It's like fucking past midnight. I doubt that. I'm not opening that door. Growth during mitosis brings spindles, affairs, growth occurs, appropriate, and I don't. So, instant. This thing sucks. So it's saying that it then does an isotropic again. Yeah, but it's already repairing the other cell to turn into the non-isotropic side, and then even if it does do another isotropic, it'll still just, yeah, get rid of the isotropic side. So it'll just regrow the fucking part that now back to an isotropic. But by that point, it should have turned into the daughter cell. It depends on how fast it'll repair. Well, I'm putting a whole bunch of repair things right next to it, so I think it'll do it pretty quickly. Yeah. How about that? Because, like, basically you're just stopping the G1 to S. Pretty much. And skipping from S to M. I'm going from G1, fuck you, repair, now go to M. It really feels like that. It's like, yo, I thought you were gonna be like this. Punch. Give me your shit. Get out of here. Go. Shoo. And then it's like, oh, I guess I'll heal really fast. Hey, what is that? I thought I said for you to stop changing. Punch. Not that way. That stuff's fine. You repair as much as you want. But not that. Got any more of this stuff? I didn't think so. What the fuck, right? Yeah, no, actually, a little bit. Now go repair yourself over there, you fucking asshole. And then it's gonna immediately, because it's like, oh, E2F proteins, go! Which is, for instance, G1 to S. So we're skipping the G2 phase. No, because S and then G2. Right, thank you. So then we're immediately, so we're getting rid of the cell. It's already got a daughter cell. And we're immediately like, yo, just immediately start the process of the S phase. Don't grow at all. Yeah. Late years how to activate cysteine D, E, G1 to S. So from G1 to S, blah blah blah, transformation, hexamer. That's all fine, actually. Truthfully, like, so it skips. What is it? Immediately starts the S process, basically, or the transition from G1 to S. It just doesn't allow it to grow. But it really forced home, like, itself into the cell. Yeah, oh yeah, it fucked it up pretty hard. It really was like that. It was like, yo, you all the way in the nucleus of the cell, go fucking, like, just give me this shit, die, bitch. Yeah. And then it's like, go back to S. Hey, you're not done doing that thing anymore? You know, and it shouldn't produce anymore. Oh, wait, no, but actually it says right here, it's like, yo, involving transition, including, oh, wait, no, inducing the expression of genes involved in the transition, including this other stuff that it produces. So it'd still keep producing the cysteine D1. The RB remains inactive. It ate its RB. It ate the shit out of its RB, so then we should just be gone at that point. You know, so it's definitely just going like, just do the thing where you repair and grow. Just do the thing. So now it's like MCM maintenance. Here's a whole bunch of protein shit and everything else to heal yourself as you're doing that. Sorry, I guess. Yeah, a little. So it's doing replication, but it doesn't need another replication, although it definitely needs a whole bunch of DNA repair. So it'll probably replicate some things. In fact, it needs all of those things, and now it's going to have a bunch of extra things to basically help its repair. Yeah. Causing termination of DNA replication initiation, which we don't technically want. Generally interferes the stability of pre-RC. Jiminin. Thank you. Licensee pressor. But, like, it doesn't, it just immediately starts the process. Yeah, it's basically trying to eat your cell. Pretty much. But you kind of want that. Yeah. It's just like, no, I don't want another cell. Yeah, I'm not looking for another cell. In fact, I'm forcing you to repair yourself pretty hard here. Enforcing a positive feedback loop. Phosphorate. Cyclin, phosphorate the RB. The RB's gone, so there's no reinforcing positive feedback loop. RB remains inactive during the M phase. It is dephosphorylated PP1 type phosphatase. It is highly expressed and activates cyclin D and cyclin E, accelerating the transition. So it induced the E2F proteins. It liberated them. Right, because you just get rid of the P107, P130 E2F transcription factors. But it doesn't say anything about the protein. It just gets rid of the transcriptions. Combined with RB during G1. So E2F4, E2F5 are found to be complex with 130 during the resting phase, and P107 and 130 in the G1 phase. Suppressive roles of these E2F transcription factors are independent of pocket proteins. And the cell shifts from S phase and binds the target promoters to inhibit transcription. Okay, so expression including system D. D required G1 G1 forms a complex with CDK4, C upregulation of transcription and system degradation protein C, then it becomes inactive, and then you get the E2F proteins, or the transcription proteins? I think they're proteins. Okay. So they were always there, inducing expression genes immediately upon its just break into the cell. So it'll immediately start its G1 to S transition. And then the RB is still inactive, so it's not going to have any of these other things. For the RB, so it'll just stay its size. It's effectively what that is, because G1 to S is just increasing size. Yeah. It's system D, system E, accelerating G1 transition. So it'll have a shit ton of these things. It'll just remain inactive until it fucking regrows itself. Yeah. RB reinforcing. So many chromosome maintenance highly conserved protein family. Transporter cell cycle in the early G1 phase. Division, chromatin, DNA, replication. Ooh, factor 1. Origin of ORC 1 through 6, and then the load MCM2-7 hexamer onto chromatin to form licensed L pre-replication complex, pre or C germinating DNA. Licensed C repressor is the initial signal. Wait a second. Give me 1 second here. Because it's still going to keep attacking if it can get into that, but the ISO will have stopped. Let me see that. So in late, it becomes polarized. So in the beginning, it's polarized, or isotropic, undergoes that, which is going to try and eat. And late, then it polarizes to initiate the formation of the daughter cell. So it's no longer doing that. Growth of the daughter cell remains polarized until early mitosis. Mitotic CDK1 induces a switch back to isotropic growth, which it's going to eat and then fuck it up again. You see here. So G22M is B CDK1, which during that formation of the secondary DNA cell grades germinating gene degrades for the G1 phase. The late G1 phase case activity of the MCM is activated CDC complex. In the S phase, the MCM complex unwinds the duplex DNA at the origin, recruits DNA polymerases, and initiates DNA synthesis during the S phase. So what I'm wondering, in all honesty, is what the fuck that RB just did. If it's like not actually active and it's not positive feedback looping. RB remains inactive until the M phase. It is dephosphorylated by PP1 type phosphatase, cysteine E-CDK2 and cysteine A/CDK2 phosphorate RB, reinforcing a positive feedback loop. Because it's like, oh, I'm now phosphorylated, so I'm gonna bind to the bind to the transcription factors. Well, no, it's just going to grow the fucking cell membrane without the isotropic. So it should still grow because it's having the G1 to S phase happen and occur. Even if RB is not trying to basically live again. Those suppressive roles are independent of those pocket proteins. Right. What the fuck does this protein do? I don't really care right now, but yes, that's a good question. I'm actually trying to figure out what the E2Fs are doing. I'm gonna get to that, so don't think I don't want to. Cell cycle transition. So we're gonna stop the cell cycle transition. Well, yeah, complex within. So those CDK4, CDK6s are just gone. Yeah, because it'll never phosphorylate RB. RB is going to die. Upregulation, and then subunit the gene promotes CKI protein. And so then that's going to happen. Actually, wait, no. The upregulation upregulation of the SCF subunit gene promotes. So the CKA protein and the cyclin E CDK2 should happen. But because that didn't happen, what is that going to lead to? Expression genes. So it's going to release all these proteins that were attached to it. But it says that they're E2F proteins. So E2F transcription factors. Alright, so I just need to know this. E2F proteins are transcription factors? Yes, they are. Suppressors, all the involved. So there's no more RB to in any way kind of hold them back. No, but they're found to be combined with RB during G1. So F1, F2, F3 are, and then F6, F7, and F8 don't care. So they're just there, and then F6 just accumulates. So then F1, F2, F3, F4, F5 are going to be fine, except the G1 phase has already started, so actually they're added. Because it says E2F4 and E2F5 are found to be complex within 130 in the quiescent, thank you, phase, and P107 and P30 in the G1, which we're going after, which we're wanting, yeah. Are independent pocket proteins. E2F6 accumulates when cells shift to the S phase and binds the target promoters to inhibit transcription. The S phase and binds the target promoters, so which remains meaningless. So basically, I'm removing E2F1 through 5 effectively, which those proteins will immediately be liberated upon this, inducing expressions of genes involved in G1 through S transition. And RB will just remain inactive, making no positive feedback loop. Is what it's saying here, reinforcing a positive feedback loop. RB is an phase and dephosphorate PP1 type phosphatase. And then it's like, what is this? What does this do? Doesn't say. I'm annoyed. You should know. No, well, you get pretty far without knowing that much. Let me just search this real quick. It's not that hard. Yeah. Promote progression. You see, promotes expression disease, the drive S. So it's just gonna release that, I guess. Because, like, why wouldn't it really? What are they bound to? Just all RB? Or is there a different RB? It just says RB. It's true, but if it's going to release from G1 to S, all of these things, with cyclin E is going to be released. But those bind to the RB. So cyclin E binds to the RB. Which has to remain inactive into the M phase. But what if it didn't? Because there's no RB. What does it mean when it's in a positive feedback loop? inactivates cell cycle regulation. So here show up on stress of P38 stress to targeting of RB. Okay. Cysteine E, CDK2, and cysteine ACD, RB. Not being stopped. What happens if cysteine E isn't stopped? I'm guessing. Is that what it is? First progression through mitosis, another delayed hyphenation, both cysteine B1. Here we go. If I knew there was someone that would fucking know. Activator system and so normally teleregulated interval to phosphorus overexpression is a reverse expression system proper latencies. Okay, just broad spectrum, like you said, super nice. Periodic expression is frequently lost, but system maintained throughout the cell cycle. So, in some cases, it says aggressive disease and poor outcome. Woo-hoo-hoo. Expression in tumor genesis, prevention, mass money. Okay. But does it get stopped by the thing? Because it's poor. It's saying it's doing it poorly. So it shouldn't continue creating them? Well, no, it started immediately the E2F proteins, 1 through 5. And so E2F would be immediately there while the cells are. It's not like it's going to immediately remove. I should say, it's not like it's going to get rid of RB. RB will come back. Yeah, it has to repair itself. Exactly. So it'll come back. Yeah. So it starts that transition. It starts doing all this other stuff. The cysteine D1 can't really be found. Why? Because there's a membrane in the way that hasn't been isoed yet. Okay. But it will in a later state of mitosis, yes. So that cysteine D1's back to form, while the RB protein will eventually, because it wants to create that. This is like genes involved in G1, which it's going to induce those expressions of cysteine D1. And it's going to try and repair during that cycle the RB, which isn't going to immediately be there ready phosphorylated, right? Does it say phosphatase? No. Let me see here. So then it has to phosphorylate. So these things are going to basically immediately phosphorylate the RB once it's repaired. So they'll be a little poor, but they won't really have much. And then once it's repaired, it should have a lot of it accumulated, so a lot of RB will suddenly get used. Or initially the first RB, and then the next, and then the next, and the next. So slowing down the cycle, slowing the rate. But it should still happen to grow. Yeah. but a slower positive feedback loop. Slower while it's repairing, by the way. Yeah, and it's gonna have a bunch of repair things around it. That's correct. Yeah, I think so. Oh. Highly conserved protein found in yeast, and DNA, and then G1 phase. So all that's still going to happen. It's still going to be okay. In fact, we'll still create another version of a daughter, but it'll be like a mother cell. It's going to eat the daughter. It's going to first eat the mother, and then it'll eat the daughter. While the repair on the mother is happening, and the daughter is then going to be repaired. All while it's still doing its standard S phase, just slower this time, while it's repairing everything else. So it wants to be extra careful about how it repairs? That's a good question. Huh. So S to G2, so it would have immediately done S, basically. S was just a slowdown. It's like it starts immediately, and then it's like slowing it down, and then like basically kind of pulls out the CD or Syslin D1 and the RB for the second time at the end, which is going to repair it again. So let's see here, and so Syslin A2, and further increased activation, resulting in commitment of in phase. It's gonna M phase, no matter what. It's gonna M phase. So that's basically, it'll still G2 phase. I still have, it's just different now. It's gonna be a different G2 phase, for sure. While it's repairing. Let me see here again about that. Like, because it's going to slow down, but it's still going to be there. Well, true. It should still be there. The RB, yeah. So the entirely regular peak in kinase occurs only for short interval near the G1 S1 boundary. Independent system, which it'll re-up that fucking phosphorylate style once it's like sure the cells are really small, but it should regrow again because it should have a sudden, well, I have more now, so do that thing. So grow back to being a properly sized cell. Should do that, like, I would imagine. One phase is definitely becoming immediate if this phase is active. This is overexpression, which we're not going to have that. I don't think so. Well, yeah, because you don't have RB. It'll just it'll be expressed immediately before it would really probably be ready to know. So it would grow quite significantly during that phase. Because the E2F genes or transcriptions. Because they're like, yo, just be all out there, Syslin E, A, D1, and, P21, CDK, yeah, all these, which just suddenly CDC25C, where did I see that in here before? Okay, Control F. CDC25C. There's 6 versions of this. So this acts as a meiotic initiator and assists in triggering cell entry into mitosis. Right, so it would immediately start mitosis, wouldn't it? Yeah, I should flood it with every one of those things, actually. So it stimulates cysteine B1, promoting G2M transition. So it would immediately start a G2 to M transition, except it wouldn't be able to do that, right? Because, of course, it still has to do all the rest of this. But it would do that. Yeah, so it wouldn't have not done that. That guy was right. Yeah. Like, he's right. Like, it would start a very fast process to mitosis. All while, like, hey, RB's gone. And it shouldn't fucking... It's like, just don't be there until M phase. And then it's like, yo, I'm regrowing during your M phase. What's up, bro? Why don't you grow me some of these other things with the cysteines and, like, heal me? You know, here's some fucking signals to heal me. Give me more nutrients, you fucker. Like, all it takes is Arby to come around and it's like, yo, bitch, I thought you said that we're going in quiescent phase. Yes, we're in a resting phase. But we wouldn't be, because we'd still be in the G1 phase. Because we basically E1, E2, F1 through 5 the shit out of it. Which it's like, do that thing now. All of it now. But it would do that. Yeah, okay, so it's doing that. So, and D1's still going to be there. It's not going to be there right away. Which D1 is the G1 through S, right? Yeah. So G1 through S would be a basic ass bitch thing, really. That it's already skipped past, so it doesn't matter. Like, it doesn't even care that it's not there. Unless it's doing something else. So let's see here. Cysteine D1 has left the whole entire conversation. Like, it's just gone. It's like, G1, well, it has this here. It's here for G1's cycle transition. Wait a second. But you got rid of it. Yeah, no, but it already does it. Because it's like, I don't need it. Because I already elicited all these other fucking cysteines. But then it's going to start creating the D1 again. Right, which is going to create the mitosis again. No, because it's already done mitosis, so it doesn't know what the fuck it's doing. No, well, maybe. You might be onto something. Give me a second. Because it's doing the SCF subunit gene, which just... It's going to super just cysteine C itself. And it's inactivated. It already has the E2F protein, so it doesn't matter. It says it's like... So it's like skipping the cysteine D requirement because the immune system attacked it. Right, yeah. Because of the isotropic, then it goes after the cysteine D1, and then it goes after the RB. And then it induces expressions of genes involving, so we already got the E2F proteins to be elicited. It doesn't matter. We didn't need the cysteine D1 to form those complexes, or did we? No, because we don't have the RB to begin with. It's true. But it'll grow it after it's done its mitosis. And it'll repair itself. So initiating, so it'll do all that. That'll be fine. And what are these other things meant for? That's a good question. S phase complex, so unwinds, which it should still do the S phase just fine. Yeah. Even if it decides to go like, hey, late stage mitosis, isotropic, I'm going to now go after those things. It doesn't need the RB. It doesn't need the cyclin. It's not going to express the cyclin E. It does need the D. It doesn't need the cyclin D. And it's not going to elicit cyclin E anymore because it completed its S to a G2 to the G2 to an M. So unless it's still using cyclin E for G2 to M phase, which does not say it is at all. And then the S to a G2 is super small. It says A2, CDK2, PLK1, and it doesn't need the cyclin E anymore. CDK2, okay, there we go. But this is A2, CDK2, cyclin A2, CDK2. So it'll have a different cyclin A2, CDK2, yeah. And then cyclin A-C, DK2, phosphorylate RB. It's all about when it starts that damn isotropic part at this point for me. I'm like, it should totally do something positive at this point. Constant, in the late stage, what does it say? Late growth polarized, growth of data into early mitosis, CDK1. So CDK1 is going to start during it's already switched over to G2 phase. So the S phase is done. It all depends on how fast it repairs that RB, which it should be able to repair it pretty fast. And cyclin D1, which it doesn't necessarily need. In fact, doesn't really necessarily need any of that at that point, because it's already done the S phase. And it's already done the G1-2 S phase. But it's starting mitosis early. Yeah. But then, does it make another replication? Well, yeah, it's going to make it should absolutely make a bigger cell. And then it's just going to eat the fucking other cell it tried to create that's new, and so it'll be extra, extra new. Yeah. More degradation of mitosis. Yes, well, no, but yes? Question mark? Like, honestly, because what I'm thinking here, okay, is it's going to form this, and then it'll be at the end of its G2 phase, and then it should turn into an M at that point. And the mitosis at the very end, late stage, will have formed everything else. And then that cell's gonna start the process of just go over there, be yourself, your brand new cell membrane. You're repairing your RB, you're doing the whole thing, you're getting it done. This one's going, I'm a brand new cell too. And I already have all my DNA and everything else. That didn't get damaged, it's still replicated, all that stuff. Well, yeah. And so then it goes, hey, but you definitely got my immune system, that is, something there that I want. See that isotropic, man, and you know that fucking cysteine D1 and that fucking RB 107 and 130 is not okay. So we're gonna take that. We should start like a secondary G1 to S. No, because it hasn't done a G1. In fact, it needs cysteine D1 to start the G1 to S. And then it also needs the RB protein, so it just grew the transcription factors, except it already accumulated a massive amount of E2 F6 to shift the F to the target hormone to inhibit transcription. So it has enough E2 F6 at the end of mitosis to no longer inscribe a elicitation of these proteins to induce expression of the cysteine A, cysteine E, P21, CDK2, CDC2, PNCA, and CDC25C. At least it shouldn't. See here. So E to found to be combined with RB during G1, which is gone. But it already repaired that during that, so it would have been. True, it would have been. And then suppressive roles of E2 F6, E2 F7 are independent. So but there's no subunit gene as a result of upregulation of the transcription. Wait, what? Yeah, because it's like, including because it's like, okay, wait. Those ERK dependent activation of the gene regulatory protein MYC, which MYC has to be, added to that. So it's like, okay, so mutagens stimulate the mitogens, gene regulatory protein, which increases the gene expression, including cysteine D, SCF subunit gene, and E2F gene. It is phosphorylation. So the phosphorylation of the RB reinforces the expression of the E2F proteins, and then as a result of the E2F proteins being expressed, it creates the feedback loop of the CYMC, cysteine D1, cysteine A, cysteine E, P21, CDK2, CDC2, PNCA, and CDC25C. But because the RB isn't there, it doesn't elicit those. So no, it would go after the cysteine D1. So what we're gonna see is a cysteine D1 non-activation of RB, which activates the. He doesn't know. What, are you kidding me? I definitely am reading this right here with you. Come on, keep up, man. Upregulation of the transcription of those genes, which is not what it's saying it's doing for that, so you can leave that alone. That's irrelevant. It's worded improperly. The RB becomes inactive. So the RB doesn't need to become inactive. So the inactivity of RB, the E2F proteins are already going to be going. So it expresses the genes involved, which means it upregulates the transcription of SCF subunit genes. And the degradation of CKI protein, thus increasing cysteine E activity, CDK2 that is. So cysteine D, E2F gene. Forensic complex. CRB can't be phosphorylated. It's going to attack it at the end of mitosis. Endomitosis will have a lot of E2F6. And binds the target with heavy transcription, which should reduce SCF subunit gene and CKI protein P27 and decrease cysteine E. Because at the end of mitosis, E2F6 will have accumulated enough. But during the beginning, it's not going to be there enough. And so during the beginning, we're skipping directly into a mitosis phase almost, but not really. So it'll go through its, well, not mitosis, although it'll start a similar version of a mitosis. But it will also be doing its S phase, or its G1 phase, while also doing its S phase, while also doing its G2 to M. Because it's all about its timing at this point. So it's like when it times, because it's like it doesn't matter that it's phosphorylated. In fact, it doesn't matter. It's just going to elicit the E2F proteins. There's not enough E2F6 as a result to suppress it, or the F7 or F8. As a result of that, we should still get the CMYC, cysteine D1, except it can't. But it can create it, and it's already trying to repair that. So that it will do that, because there's enough around. So it will still make that happen. So it's just going to start repairing the cell membrane. So it'll start pushing it out a little bit. Because the membrane's not there. Well, part of it isn't. It's going to go after the membrane because of the isotropic. Then it's going to go into for the cysteine D. And then the cysteine D is close enough to where it can start detecting the RB protein. Yeah, I mean, it should be close-ish. I mean, it's going to... I mean, yes, no, it doesn't go outside the nucleus, is what you want to say. But it has to move. Those RB107 or 130 proteins have to move to elicit the expression of cysteine E CDK2 activity. Or, I'm sorry, No, it has to express... Yeah, no, it has to... So those proteins are gonna get there. Like, they have to do something. They have to come from the nucleus. They have to transfer. They have to express. Yeah. Which should eventually... Because there's no cysteine D to phosphorylation? Okay, phosphorylation. Don't fucking mix my words, dumbass. Phosphorylation, which is basically sounding it out. Yeah, who doesn't? Phosphorylation of RB, but because RB can't be phosphorylated, thanks to the CD1 not being there, it then means we skip from that on over to a no longer Syslin E CDK2 activity. In fact, but we should still get a transcription of SCF subunit gene and CKI protein P27, because those are still going to upregulate it. So those are still happening. So Syslin E is still going to happen. The cell membrane is going to repair itself. Right, but RB protein still has to move. It has to bind to E2F. Which is in the nucleus, so the E2F is going to be unbound. Yeah. If it can get to it. Yeah, but it's in the outer side of the Syslin D. The whatever it is, cyto fucking plasma, no, not plasma, membrane, cytoplasma membrane or something like that. Is it cytoplasma membrane? Is that what it is? Cytoplasma membrane. Yeah. That's where it moves to. Which is pretty close. How close is the cytoplasma? So location. It's a nuclear membrane. It's between a nuclear membrane. It's fairly close. It's not close enough. No, you're right though. So nuclear membrane is right there. Yeah, but it's not gonna be a fucking nice guy about it, dude. Do you think it's like cutting it out with a scalpel? It's a fucking goddamn immune cell. Let me just immune cell scalpel that. Is what it's gonna go through. Of course it's gonna get in there. Why wouldn't it? I mean, how far does it cut it? So immune system attacker. So immune system attacking cells. How does, okay, you know what? Let me look at that up. How the immune system, immune cells attack other cells. Neutrophils, polymorphonuclear, whatever, PMNs are the type of white blood cell. Rapidly inject microorganisms, kills them through a process called phagocytosis. Very close to bad words here. So, what is the phagocytosis process? It's sensing and taking in particles larger than about half a nanometer. Particles internalized. Now, is it a micrometer or a nanometer? Whatever, doesn't matter. It's that size. Distinctive organelle and so it changes the structures, membrane encompasses as part of the physical. So, what's this? Okay, let me see this. So, distance of cytoplasma membrane to nucleus. So nucleus. Yeah, I got it right. Okay. Alright, so the area between it, yes, no, I get that. What's the distance? 30 to 50 nanometers. Two vibrators, nuclear. It says nanometers. What's that U? Is that micrometers or nanometers? That's a good question. I've forgotten. What does UM stand for? Pretty sure it's nano. Micro. Fucking shit, it's a micrometer? It's gonna go in for it. It's gonna go. Hey, you nucleus. Narn, narn. I thought you didn't like me. Narn. You were so far away. Narn, narn. I'm eating you in 50. Half. It's still a micrometer. It's still a 50 nanometer distance. So it's gonna eat it into the fucking nucleus. Thank you. The nerves. I'm just wondering, honestly. Micrometer. How did I learn? I was just thinking about in basic bitch immortality. Really? Yeah, basic immortality. I skipped off of something I was gonna do for like our fucking stem cell thing, and now I'm like realizing like, hey, you know what? This is still not a terrible way, really, if I could like brute force it. Yeah, I just felt about it. I'm like, you know, these are basic questions that some people have to ask eventually. Alright, so larger than 50 nanometers. Shit. It's gonna get in there, man. Which means it'll suddenly detect that fucker. In fact, it's 50 nanometers in the cell membrane, and then you get your cytoplasm, you know. It's gonna really eat the shit out of a fucking cell. And that, cell structure. I wanna look at this. Distance between membrane and cytoplasm it's gonna get in there, dude. It's not. I mean, it's basically the same distance between cytoplasm to the fucking goddamn nucleus. It's for sure eating the fuck out of it, man. So it's getting in there. We'll just say it does. Whatever. So angry about it. Jeez. Alright. Increasing cysteine E activity. So it will just suddenly upregulate the shit out of the SCF and then the CKI and cysteine E activity. But we don't have cysteine D1. So, and we pretty much don't have RB at that point. Not to mention, most of that cell is hurt. It's not gonna kill it, though. It's certainly gonna make it feel hurty. Real hurty. Like, lots of hurting is happening. And I'm growing, you bastards! I was supposed to be fucking treated nicely. We are human. Get used to it. That's the outside too. Jeez. Oh, it'll teach you how to be better somehow. Somehow. Yeah, we're figuring out how. Really, if we're being honest. So it shouldn't. Well, I mean, E2F1 through 5 are going to be bound to RB, so they're just going to flood. Yeah. Because it's like they're combined. Yeah, so E2F1 through 3 are definitely combined through RB. And so through also, yeah, so they're just going to flood. They won't fucking go back and like phosphorize it, making it inactive. In fact, it's just gonna go flood because the monster came into the house. Arm, arm, arm. God damn it! Immune systems. All right, so you're gonna eat the hell out of it. E2 proteins. Hey, what do you know? Flood. What creates cyclin D1? That's a good question. And I'll have more than enough around, right? I think so. What creates cyclin D1? Producers must. No. There we go. How's it produced? Growth factors. Okay. It'll have growth factors. They're not going away. It's true. They're going to have growth factors, okay. It's also going to be flooded with a bunch of things to repair the damn fucking cell membrane, which is what it wants. And help out the... Yeah, no, the DNA. Yeah. Because you're doing an enzyme complex. Yeah. Right, so like the membrane's going to fucking form fine. And then growth factors extraordinaire, right? Yeah, yo, RAS, RAF, and ERK in the house. Get up on stage, guys. We need this shit because we just produced a fuck ton of cyclin E. We've got like the CY or CMYC, the cyclin or the cyclin A's, the P21, the CDK2, CDC2, the P. Oh my god, yeah, it's gonna fucking for sure. Just skip all that stuff. Well, I know what you're trying to say, because it's like the activation gene regulator protein NYC is for sure is NYC the same as CYMC. Yeah, is NYC the same as CYMC? Damn it, wrong one. NYC. There we go. Ah, you bastard. CMYC. Alright. So it's C and N and L. Ah, it's the same thing. They just didn't specify. Okay. Well. So, what does that mean? So it's gonna force ERK dependent activation because it's like those are already going, even though cyclin D isn't going. Mutagen, so it's like it started off the process, then it created the ISO, then they're still gonna keep going. Then it eats the membrane. It goes fuck you D. It goes fuck you RB. Eats the hell out of it. It goes, hey, repair yourself, whatever, bitch. And then lots of cyclin E, CDK2, and cyclin A, CDK2 start. Well, I mean, that's later, most likely. And so, but the SCF subunit gene and then the CKI protein is going to degrade. The CKI protein 27 P27 is going to degrade, increasing that amount of cysteine E CK DK with the E2Fs going, keep producing more of them. Like, they should just really just flood it with all the CMYCs, cysteine A's, cysteine E's, P21s are, I don't know where the hell that one, it's just says P21. We already know the CDK2s, there's a couple. The CDC2, and that one's kind of different. The PNCA, I don't know what that one is. I remember this one being about the mitosis. So, liberation of all of that. But then that gene is going to suddenly flood it with cysteine E. While all of that's also being fucking added. But it has to do it in a stage. Yeah. Huh. It can't do it all at once. That's the problem I'm having. Which is during which time? As it goes, RB? Never heard of them. Have them all. E2F in the house. 1, 2, 3, 4, 5. And then, I don't know. It's kind of weird. Let me see here. So what is this one used for? So it's going to start the freaking S phase. Oh yeah, no, the S phase started no matter what. During it, like a cell membrane break? Yeah, but it's repairing the membrane with a whole bunch of shit around it. And it also goes like, grow, fuck you. I said grow. It's like looking at a flower you cut, and it's like, grow better, bitch. But you started laughing really hard, and then you realized right there, we do that though to make certain types of growth occur. That's true. But does it, like, specifically one to the next for our E2Fs? Is that what causes the one, types of things? I don't know. It's not really saying. MCM complex is activated by CDC45 MC2-7 GINS complex. So it should flood all of those. In fact, RB is not going to be like taking up any of because that's what it is. So RB is going to basically remain inactive. That's fine. It can come back. It takes a while, but it can come back. Yeah. But then the cysteine E, CDK2, and CD, which we said is going to phosphorize or phosphorylate RB, which that phosphorylation of RB elicits E2F. They're just going to flood. All the E2F proteins are going to flood. Instead of doing it like a little bit, it's just going to go bang, go, grow. Mitosis at the same time as S, at the same time as G2. But we don't know what those E2s do. Those E2Fs, which ones do what? It doesn't say here at all. And all the rest of them are still going to be there. For the cysteine A2s, cysteine Bs, the B1, B2, B3 systems, So they should still mitosis appropriately. And then cysteine D is still going to come back during the growth phase. And then it goes, hey, yo, you stupid cunt. Exactly, no kidding. Eat the hell out of my fucking membrane. Yeah, my cysteine. Oh, my RB. My house has been invaded by a big bad monster immune cell. No. More E2 for you. Grow, bitch. Grow. Which, though the mitosis happened quickly and everything else kind of went fast, it doesn't matter, it'll grow back. He's right, he got it right then. He's just fucking proving his point at that point. It's like, oh yeah, no, mitosis pretty quickly, not too quickly. Go through all your stages faster now. Oh, but by the way, close everything really quickly and then grow. Fucking become bigger. But it does have another problem. Oh yes, the caveat of the fact that it'll run away growth. While they're... Really? You don't say. Well, no, I mean, it shouldn't because there's E2 F6s. Yeah, okay, right. Because the F6 is there, in fact, along with the other suppressant E2s. Yeah. So RB's like, hey, I'm gone. Here's the ones that say to express yourself. But I have a bunch now that say don't fucking do it. So it should slow down and not grow as much and not start the process all over again. But it doesn't say that it should elicit all the rest of the proteins. Right? Mm-hmm. Because by that point, the SCF subunit gene and the CKI protein deprivation should no longer be increasing cyclin ECDK2 activity. So while the E2F, it's like, oh, I've just done all the things. It's like, that's literally, it's like a drug at that point. It's like shot full of dopamine. 6 hours later, shot full of dopamine. Okay. Yeah, I guess. It's really exactly that. Yeah. I already started the other process. That's correct. See, because it started the process of the division. This came in and broke it all the fuck up. While it's repairing, it grew. It then started its process of doing the whole splitting up thing. But it forced it to start the process of closing off things faster. But it's all about when it released things. That's the... Yeah, okay. Give me a second here. So E2 F1 through 3 are going to be the G1 phase, which is a growth phase. Okay? And that's the majority of what's going to be there? No, because E2 F4 through F8, those suppressive, although 2 of them are during also the G1 growth phase, And E2F6 accumulates when cells shift to S phase, promotes inhibitor transcription. Let me see this. So, You know what? It doesn't really say anything about the E2s, the E2Fs being the qualifier if then, and then it does it, and so this then calls over to here, and then it says now do this. It doesn't say anything about that. Feminine is still gonna happen. And all the rest of that's still gonna go and happen. And it's all gonna happen too. That's true. So let's see here. In the endomitosis, membrane growth is polarized at the site of cytokinesis, driving the addition of the membrane necessary to complete the cell separation. Which now we're going to look back at this. Oh, there's another thing I opened. So let's see here. It'll get through all of its regular activity. Should be fine. Until we get to cell separation. Cysteine B1 rapidly degrades and disappears at the middle. So let's see, a common central transition, and it's looking for CGC25B. So both cysteine B CD1K1 modulates centrosomal microtubule nucleation at the G2M transition. It marks interval in assisting both G1S and G2M progression by dephosphorylating CDK4, CDK6, as well as CDK2, CDK1. So going to dephosphorate CDK2 and CDK1, but there's no cysteine D1, which is the CDK4, CDK6. So B is still going to be fine, D is gone. So we don't really need it. It's true. Hmm. Hmm. Inactivation of CDK1. We're not doing that. Rapid cessation of polar growth. Which we're not doing that. Polar growth, which is fine. So CDK1 is still good. So activation of GLN systems activate CDK1, which we didn't do. Which we definitely still got CDC25B from what we saw at the top here, CD25C. Where does B come from? It doesn't say, question mark. Hierarchy, so it's mainly functions to regulate G1 to estrogen system. There's just 3 CDC25s. Proliferating nuclear cell antigen, DNA, does its thing. There's a marker for the S phase. These things regulate it, acts as a meiotic. So I guess it just starts that process once we get to the PCNA. Once we start the rest of it, I mean, the rest of it's still going to happen. Yeah, all the rest of it's still going to happen. So MCM's still going to happen. Cell division 6 still happening. DNA replication 1 still happening. ORC 1 through 6 is happening. MCM 2-7 hexamer is going to happen. Chromatin is going to happen. Licensed pre-replication complex is going to happen. Geminin is going to happen. Nothing stopped happening. It's still going to happen. Should still happen just fine. The isomer should still happen. Huh. I mean, isotropic. Oh, isotropic. Thank you, yes. So, polar growth will still happen. And the membrane's still going to happen. Yeah. Huh. So, polar growth. So specific image of the button causes rapid cessation, required by the initiation and polar growth. Well, the rest of it's still gonna cut it down the middle, if we're being honest. Polarizes actin, cytoskeleton, direct membrane traffic of polar growth. Researchers may also control membrane trafficking events that play a role in membrane growth. So the CDK1 is still going to happen. So it'll still create polarization. Vesicle fusion. Depolarized actin skeleton or mutants that block vesicle fusion growth sites. Which cause extensive accumulation of vesicles in vivo, tracking post-Golgi vesicles after inhibition. Vesicles may be inappropriately transported into a vacuole. Although it was not possible to rule out other fates, inhibition did not appear to cause defects in BGL2 or invertase, nor did it cause defects in targeting GFP, SEC4 at the site of cytokinesis. Together, these observations suggest that CDK1 controls membrane trafficking events, mediate membrane growth. Could do this by initiating events, so delivery in absence, delivered to the default pathway. Membrane traffic are unknown, although proteomic screen for targets of the CDK1 identify numerous proteins involved in membrane traffic. Little is known about the signals initiating isotropic membrane growth occurs before bud emergence and G1 phase, which are likely to be CDK1 independent. But it should still cut itself. Yeah, down the middle. And should still create all the rest of it. There's no middle. You see him? Fuck off. It's just an A. That's still gonna happen. Some B still happening. More resulting in commitment to M phase still going on. Detection of Bohr from SCF dependent degradation still going on. It's profound. That should still happen. That it's gonna happen. That's gonna happen. So it'll attack it around the time it's basically already good to go. Running G to M changes in the middle of the telophase mitosis at the same time cell exits. Is the next cell cycle. System B1 CDK1 activity promoting G to M, which will G2 to M transition, which would still occur. Yeah. Yeah, okay. And it's until it polarizes, which it'll take a while to do. I don't know how long. It's terminated. The extent of memory specific which could be influenced by their cell size and shape. Which is early mitosis. Resistant to link between polar membrane growth and CDK1 activation. Slowing down CDK1 activation for growth will allow for all the rest of it to happen. But it happens really, really quickly, and then it doesn't do it for a long time, and then it happens basically at the very last second at the end, it seems like. Protein, can I see? This is going to sound pretty, folks. But what we know is that we don't know shit, apparently, about that. We don't. We don't know when it's going to polarize. We know it'll polarize almost immediately, and we know it'll polarize pretty much at the end. So, have a double activation of a regrowth factor of these various E2F proteins, which is going to grow again twice and then be left alone. Yeah. Yes. Huh. That's the thing. It's like, okay, so it starts off, it digs in, it's going to heal, grow, start the process, split, start the splitting process. At the very end, it's going to do its polar, it's going to dig in, start the process of growing, it's going to split. Well, no, because the E2F suppressor transcriptions should be greater, so they shouldn't split, if that's what they do. Let's say that's what they do. Let's say that. Then the very fast trying to heal protein shit that's around it got all these other proteins around it that are trying to help the cell membrane rapidly grow and heal. Which you do. You can be angry all you want, but you do. Taking the pills, bro. Alright, then it's going to eat what? Doesn't matter. Point is, it's going to regrow. Going to fire off a lot of E2s. Going to be upregulating certain gene expressions. Right? Well, there's no system D again. We don't care. E2F genes, there's an increase of E2F6, inhibiting transcription, which RB was inhibiting transcription of the E2Fs. So E2F6 will be a very significant suppressor along with F7 and F8 because it's going to accumulate, like I'm saying, which should reduce the overall effects of E2, F1, F2, and F3 respectively, even though it doesn't have RB. And as a result, while somewhat of a growth is going to occur. Cyslin E, CDK2 is not going to really happen as much because the upregulation transcription isn't going to occur. Basically, what I'm seeing here is it's going to hit a point where it's not going to happen anymore. Like, no matter what, like, it's going to hit a point where it's just not going to do it anymore. Like, yeah, so, like, maybe it does it again, and it makes another cell. It heals over there, maybe it does it again. But eventually, there'll be enough fucking E2, F6, F7, and F8 to just not do it anymore. And so the upregulation of those transcriptions for the SCF subunit gene and the rest aren't going to happen, thus stopping the process of the cell division. So, for one cell division, I'll probably get a couple more cell divisions as a result of this. And they should be pretty good repaired, cell divisions. All right. So after looking at all of it for a few hours, it looks like it will have cell division continue with the cell membrane nucleus. God damn it. Spelling. Furby, I swear I love you, but come on. Nucleus. That should be about it, right? And the cytoplasm. Yeah, right. Cytoplasm. Membrane. Holding cyclin. We've been saying it wrong this entire time. Cyclin D1. I bet you that annoyed the shit out of certain people. But thank you for the help. Cyclin D1, the immune cell will absolutely dig into the nucleus and nucleus. There it is. Looks like I'll have cell division continue with the cell membrane. Okay, so let's see here. I wrote that way weird. Yeah, okay. So after looking at all of it for a few hours, looks like I'll have cell division continue with the cell membrane while it's dividing. It's dividing. Then once more at the end of its division, the immune cell holding the signal and the so the cytoplasm. Well, actually, yeah, it should do that. As you know that. Looked at it for a few hours. The cytoplasm membrane holding the cyslin D1, the nucleus. I couldn't see another one. and nucleus. God damn it, I fucking hate spelling sometimes. The nucleus will be eaten by the immune system. Then another division will take place until the E2F, what was it, 6 through 8? 6 through, what is it? 6 through 8. F6 through F8. E2, F8 proteins will accumulate and suppress why is it that I can't spell that right? Yeah, it's 2 P's, that's what it was. Anyways, suppress the continuation of cell division. Because RB will eventually come back and be repaired and cyclin D1 as well. It just takes time. Then the cell membranes and innards will have been repaired as well. Repaired too. Oh, there's an A there. That's what that was. Repaired. Reaping the repair. 2. Okay. Now it's sent. Those my likes? What is this? Did I ever? Oh, I did tweet that. So that's plump, by the way, folks. That's what plump means. That's what plump means. People are like, plump, you're morbidly obese. That's not plump. Stop saying you're plump. They always want to be, I'm plump. And you're not, though. You're not plump. Stop trying to just say you're plump, please. That's all I'm asking for. But, like, you know, whatever. You know, whatever. Truthfully, every time I think about it. Really? Yeah, no, because it's like, whatever. My judgment, right? What does plump mean? It's a spectrum of morbidly obese to apparently I'm stick thin. How does that? What? And I have to go along with that totally impossibly right fucking, you know, thought process. It's incorrect. There's a point where plump, because it's a big word. It's like a slightly big word. You know, it's like a bump. You know, and you hear it, it's like a bump. You know what I mean? A whoomp. You know what I mean? It's like a marshmallow. You know, it's not like a fucking marshmallow. It's like a marshmallow. It's a plump. It comes from plum, which not the largest fucking fruits. you look at them, apples can be bigger than plums, although some can be bigger than apples. I don't want to get into that. Doesn't matter. I don't care. What does it mean anymore? It just means plump. I know. But see, like, plump is like that to me. Although the tits are too damn big to me. Like, those are ginormous whammos. Like, what the fuck? But that's plump. You know what I mean? It's got a little bit of a tummy. It's got some hips. And there's even, like, love handles. That's plump. Yeah, okay. I can see how that's plump. Okay, whatever, man. People get so angry. Yeah, I don't want to get into it. Do you know how much anger was spewed towards me during my Reddit? Oh, I made a small, WDT. It's not WDT. It is paperclip and guac. It works fairly well. It does not work at all. What the I wish they were that nice, honestly. You know, the worst part about that is, like, I'm going to tell you exactly how toxic and negative you're being. People love that, right? They don't. I'm definitely being sarcastic. Ooh. Oh my god, you're fucking so fucking, like, you're inciting, you're trolling, you're the one that's creating the problems and issues and rage. I'm like, because you're being told how fucking, like, stupidly toxic and negative you're being? You're autistic. No, not that. You're a rapist because you participated in the Rape King community on subreddit. I'm like, I made a couple comments a while back. It doesn't make me a rapist. And they're like, you're throwing out accusations in big words. You know, this lettuce girl person, I don't know who they are really. And I'm like, so are you. They don't ever want to agree. They always want to fucking fight me. Anyway, so we need to do the Cas9 system setup. Going back to the original that we disappeared onto this rabbit hole to make sure that that thing would work. We have to finish this. Because we have, what was it again? The fucking, L word with the fucking how you determine things. Markers? Yeah, something with markers. Yeah, fucking shit. Lineage cell markers. That's what it was. And then cell surface markers. So yeah, right. So positive cell surfaces markers, right? Something like that. So surface cell, e.g., so there's a characteristics cell surface markers, mRNAs, or internal proteins. So we need lineage cell markers for the Cas9 to be attached to the CRISPR-Cas9 system. Alright, and so if we do that, where are we going to head towards? Well, we're hoping to head towards... I mean, exactly, you have to constantly keep injecting yourself to hit those cells. Yeah. So it's like, what are the linear... So we have to go with the what is it the fucking thing was called again? From embryonic endothelial cells. So we have to hit embryonic endothelial cell through lineage markers. So if we can get those done, precursors calls, I don't care about the precursors. I want to hit those fuckers. No. Yeah, no kidding, right? Like, do the angioblasts happen to, like, differentiate into endothelium and embryonic blood vessels? Angioblasts are created? Endothelial has to be created. Or angioblasts being... So, do endothelial... The leal cells stay? Are they permanent? Is a better way to put that. Yeah. Endothelial cells permanent. There we go. Is a continuous organ which enables tissue function and regeneration in hemostasis. So it lasts 1 year. So you have to take a injection 1 year with your Cas9. I could do that though, honestly. But why not? Okay, so what are they come from angioblasts. Angioblasts, yeah. So how long do angioblasts take? How long do angioblasts last, I guess? They're found in vascular, so 2 weeks. Endothelial. We're doing endothelial, yeah. Sorry, folks, we're doing endothelial. Because the last 2 weeks. Yeah, everything. What the fuck causes those? I don't know. Let's go. What causes angioblasts? So it's a vague. So VEGF-A express several vascular endothelial cell markers, including the Ty1, Ty2 receptors, vascular endothelial VE-CAT. Oh, Ty, by the way, I love this. My older sister and I argued about that. We had this little card game that they were supposed to create like a debate about various random topics. Totally a random off topic here. So just stay with me. We'll get back to it. Debate between the spoon versus a fork being better. And she won because everybody was just like, I agree with Amber, my older sister. And not because like she had a merit to her argument being logical or even emotional or anything. Just they liked her. And they liked the fork, I guess, a little more as a result, which is a bias as a result of projection being there from the person that they like projected towards the fork that they also happen to like, which we see with celebrities endorsing certain products, and therefore we will allow ourselves the justification of spending the money on that product. You get the gist. Where am I going with this? Well, okay, so the spoon's a better pick. In every way, it's a better pick. More foods that you eat will be better with a spoon. On average. Not every fucking one. Unless it can be eaten by your hand. It's like when you need a utensil, it's like you're most likely wanting a spoon. Not a fork. A spoon. Because you can still hold down with a spoon the piece of meat with the flat side of the spoon. I don't need to push tongs into it. And if I have a sharp enough knife, I don't need it to be that good at spearing it into place. There's ice cream, there's soups, there's salads. If they're chopped up small enough pieces, they're actually better with a spoon. Because I can now get the little olives, onions, croutons. So where am I going with this? It has to do with some other fucking fuckheads online saying that they were better about something, but they just made an emotional bullshit argument. And they were like, we won because we're better. But you just like the thing, the person, and so you all join that. But in reality, their arguments were garbage. It has to do with Republican garbage, anarchist crap. Back now into this, though. Vascular affinity. So they come from that. We could target. We'd have to do it every 2 weeks. Yeah, what stimulates that? I'd rather just do endothelial. Thelial. Yeah. Thelial. Anyways. Let's just get the embryonic endothelial cells going, because it's still going to last a year or so. And who knows, maybe you want to change it in a year. You never know, you know? You might want to, yeah. So, we're going to use lineage cell markers to target embryonic endothelial cells to do what? Change the hematopoietic stem cells, creating. So we're going to target those cells to create those in a different way. We're just going to give them a new DNA. They're still going to do that. They're still going to do that thing. Like, they're still doing that thing. No matter what anyone says, that thing's being done. So, we still want them to be those cells and to turn into those cells. We don't want to fuck around with anything but their DNA. Because that's all a CRISPR-Cas9 can give us anyways. So what are you wanting it to do? That's the best part right there. It's like, if I can make it so that way it searches for the very markers that we're looking for anyways. The isotropic protein for a cell membrane. The cyclin D1 and RB protein 107-130, we should still be able to get the results we're looking for, except we don't have the exactly right there. It's like there are things that produce those things for us, for those enzymes and mRNA complexes. Yes. Can we do it more? I don't know. That'd be a good thing to have. It would be, yeah. So where do you really want to do it? Well, I mean, it's my past thing now. I'm like, oh, I wanted to do this. You know what I mean? And it's like, now this isn't even a thing anymore, it feels like. Did that ever upload? This fucker. It didn't upload. You fucking what? No. Google Drive likes stuff waiting for the network. My buttocks are definitely not having that shit. Fuck you. Fuck you hard. Is this uploading? Oh, it uploaded. Holy shit, hole. Whoops. Okay, give me a second here. Why the fuck is it doing that? I couldn't tell you, man. Really? Has it done that before? Nope. Ever? It has never once done that before. Except for the time before. It's been uploading just fine all last 3, 4, 5 days. So, lineage markers for those cells. Yeah, but I needed to create something special. Really? Yeah, no, I wanted to create, like, the immune system cells that I really need. Not like, kind of, it's okay. You know, it goes after these, it's whatever. You know, it's, whatever. I don't want it, like, whatever, you know? I wanted to make stem cells. And so, instead of attacking it and then having it repair, what I'm looking for is it to attack, but then have it repair with that protein. To change it into the... Shit, what the hell is that called again? Do you want an angioblast? I can't turn into any fucking cell, can it? Let me see there. Angioblasts turn into any cell? No. No, I cannot do it. Sorry. So, stem cell creation. Blastocysts. Genetic reprogramming, which is what I was talking about in the past. Yeah, give me what it is you do to make the stem cells. That DNA changes are made to create stem cells. There we are. Folks, you fucking what? Okay, alright. Skin cell to stem cell. So there's a lot of them every time. Are they? Yeah, because they put it there, right there, the first time. There it is. There's the one. It's the Harvard EVU. EDU, not VU. So there you go. So SOX2, OCT4, and CYMC into our cells. Is viruses. But we don't need viruses. In fact, we actually have a DNA. What is that one that we just had in my history for a second there? It is a group of promising. Kisea Bio. Whatever the fuck this is. So, what is I was looking for again? No. This thing. Where is it? So, here we are. DNA replication licensing factor cell division cycle 6 and chromatin licensing DNA replication factor CDT1 is recruited to the replication origin by the ORC 1 through 6 and then load the MCM2-7 hexamer onto the chromatin to form the licensed pre-replication complex pre-RC. Okay. So basically I targeted to have multiple different changes here with the immune system. To change it into something that has a version. Just give me a second. Because that would be wonderful, but why? It's the fact that the DNA isn't going to synthesize back and be repaired correctly. And I need to make sure it does. Because it's going to attack. Well, that's fine. I don't mind that. In fact, that's probably a better thing. It gets me into the nucleus easier. And then it's going to repair itself. Where did it say it was doing this? DNA circle 6. Yeah, only once per cell cycle in eukaryotes. Orc. Orc. Repressor is the initial signal to transformation to G1 phase to S phase. S phase to G2. Signal initiation. Blah 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 blah. Resulting in the commitment to M phase. They really don't much know what S to G2 seems to be all that about. It's quite smaller than G1 and or even G2. Huh. I don't even know if it actually has much more going on, so just gonna leave that one alone. So it's DNA synthesis. Here it is. DNA pol. What the fuck is even that? I don't even know how to say that. What is this? Polymerase. Fuck you and fuck you. We've got like the stupid college frat party, stupid fraternity fucks, letters coming in. Epsilon. Thank you. And this fucker, who's he? Look off, Epsilon. What are you? Tau? This is delta? Lowercase. That's a fucking delta. Okay, it's a delta. Just give me a fucking stupid triangle like anyone else, you cunts. I know what the triangle means. It's a cofactor of DNA polymerase delta epsilon. It exerts roles in DNA synthesis as the maturation of the Ozaki fragments. Which has to turn into the Ozaki fragments somewhere above, somewhere in this. QHG2 peaks at M phase, complex APC, anaphase, instruction box mutation, Geminin, thank you, degrades before the next G1 phase, and late G1 phase, the helicase activity in MCM complex is activated by the CDC45 MCM2-7 Gens complex. Oy, Crimea River, I don't give a fuck about that. I want to know what makes you tick for making the DNA basically turn out to be the DNA it needs to be. It has a DNA on file somewhere. I need to know why the fuck it does that and how we can change that. And it's not really telling you. It doesn't seem like it, but it has to be inside this thing because it's doing it during division. It's not doing it. I know. Ha ha ha. I know and you don't. Says the one spending $25,000 this year just to fucking get drunk and not pass any of her classes. I do meth too. Why don't you talk about that? I don't feel like I need to hit you even harder, but have fun. Dude, you're the one laughing. I don't find it funny. I'm just trying to figure this part out. So it's the PCNA antigen required for DNA replication and repair, which it needs to know these polymerases for synthesis. But that's synthesis of something it already knows for sure it is. So it has to know for sure what it was beforehand. The chromatin lysine origin. It really doesn't say. Okay, I guess I'm gonna have to go just like without actual pointed, this is what we need to target stuff. Great, swell. Let me look at this. Well, I'm bored, and what proteins hold the information of our DNA during mitosis? Chromatin proteins and RNA associated DNA. And this is like carry epigenetic the DNA cell. So this is NCBI.N blah blah blah. National Library of Medicine, National Center for Biotechnology Information.gov. Good old test cases, aren't they all? Companies. Okay. That could be bad. What? So using a combination of proximity ligation. I'm in fucking goddamn trouble, guys. I'm in court. I need ligations. I think you mean litigation. Assay-based techniques and super resolution microscopy. Yeah, that's on purpose, I know. Got you. Microscopy, whatever. Fuck off. It all sounds wrong to us at this point. We found that the number of protein DNA in RNA-DNA foci undergoes significant reduction during mitosis, suggesting that mitosis may be accompanied by structural rearrangement or compaction of specific chromatin domains. Which is why I said, uh-oh. This doesn't sound like telomerase reduction. Histone, cystone modifiers, nucleosome remodeling, transcription machinery, non-coding RNAs. During all some stages of mitosis, while others remain mitotic chromosomes. Until recently, the fate of transcripts during mitosis was unknown. Still. It doesn't tell me this means that, and so that means this can do these things. It's just telling me a whole bunch of random garbage I don't care about. What protein, what helps DNA stay the same? Actually, that's fair. Stay the same during mitosis. You fucking asshole. Chromatids. So it just uses a protein that basically switches it to the opposite thing that the DNA is made out of. Phosphorus, all the rest of it. Right, I remember that in fucking biology. Thank you. I appreciate that tremendously. So, what are we trying to do? Well, I mean, it's a chromatin, so, I mean... We're looking at DNA strands, and we want to target a very... Goddamn... Not secure. Go to the site. Fuck you. Why are you... Which should make it so it doesn't affect your sex cells or, that kind of stuff if we do this. So it should be fine and pass inspection for legalities. And how would you know that? Because it doesn't affect anything other than eukaryotes, which are not the prokaryotes, which are the sex cells that you ejaculate into your wife, or your wife fucking has drop out her pussy when she's on her period. Okay, enough. So, we'll just use a protein that basically is attached to your immune system's cells. As it attacks, it goes, do this, I guess, what's the protein? It doesn't fucking really matter. I don't know what the protein is, if I'm honest. Truthfully, yeah, well, who gives a shit? I could probably say it's, which one of these is there in the cycle that's going on around then? Unwinds the duplex DNA at origins. And then recruits DNA polymers. So we're going to use the DNA polymers epsilon delta and initiate DNA synthesis with the correct now change to the DNA's structure, no, it's the Cas9 thing. What? So it's like, hey, do it this way. Literally, that's what it says. It's basically, it's like, yo, this is like dumping some polymers, epsilon and delta, over to you. That's different than your shit. That's all I need to do. It's like, nom nom, DNA polymerases. Here's this shit. Have fun. Fuck off. Don't come back. Really? Yeah. It doesn't dump it? Yes. No, of course immune system cells dump shit out. Immune system excretion. System secretion. Excretion, cytokines, chemokines, mesas, sensory, whatever. I could have it fucking dump out some polymerases. Can you? I don't see why it wouldn't be able to. I mean, I'm changing a fucking embryonic endothelial cell to have a different DNA setup to create immune systems that do that. The cells doing that, yeah. After they attack during an isotropic switch to its protein in the cell membrane. That is correct. With the cyclin? Cyclin. D1 and RB107130. It should still inhibit, basically, it should still start the whole mitosis process off. Every time it tries to do the mitosis process, it just breaks down the cell membrane. It goes, hey, fuck you, here's some polymers for the new ones that we want. The DNA changes, that is. Okay, and then we already know that it should eventually stop replicating. Yeah. Like, well, you probably wouldn't get more than one more replication. I would highly doubt even one more. But you might get one. Yeah. For one, I get 3 by beating it to death, motherfucker. I know. It's like, it's not to death, but it's like, bitch, I told you to give me more. I'll give you one more. I'm repairing myself. I don't have any more ETFs, motherfucker. Go away. I just have the suppressors. Get the fuck out of here. I don't want to play no more. But basically, that's all that's going to turn into. It's just getting the immune system to have a polymers. So, kind of cytokine or chemokine release right range with adaptive immunity. It has to. When it eats something, it doesn't just die, does it? Like, it has to have excretions. It needs to have waste. Immune cell waste. Clearance in the to accelerate supercharged immune system. I don't see anything about that. And I don't see anyone that's ever tried to fucking see if there is or isn't. It says it eats waste. Yeah, but it doesn't. It can't just continue keeping shit inside of it. It has to be turning into a cytokinine or chemokinase or whatever the fuck it was. Cytokinine, yeah, chemo. So, immune cell secretion creation. Brute forth methodologies do work. Don't you? No, I don't care about the creation. I want to know how it creates its secretions. Pro-inflammatory cytokines. We don't even know the DNA. That's true. I mean, it'd be easier just to inject shit into someone's, fucking area to make it work. Wait, why? Yeah, just have a carrier. Exactly. That's all I'm saying. Like, have a carrier that just deposits it. What? It's true. We can just make it an immune system cell that is new. Instead of being like, we need to be all about making an immune cell that we already have for fucking millions of years. Suddenly change dramatically and fucking be super cool and have multiple functions at once. No! That's so hard. I don't know how to do any of that. Can you not? Dude, what do you want me to do? Just fucking make a new one. That's super simple, and it just fucking shoots, like, polymerases over into their fucking gullets and makes it better. That's not easier. It's already got immune cells right there. It can absolutely be like, you know what? Hey, this motherfucker's gonna be that one. You know what? So you were gonna be 2. Now you just get the 1. Okay? You just get the 1 T white blood. I don't give a shit anymore. Now you got this one. Okay. So, what would it be targeting? It's another protein. That's literally, it's going to be a virus. I'm not even going to lie. It's literally going to be like an immune cell virus. And I'm like, I don't want a fucking like big ginormous thing. I need this thing to literally go, hey you! Yeah, take that. That's honestly, it kind of acts like it does a little. It's like, it is just a marker. Here you go. Shit on you. They're that simple. And so I just need them to go like, yo, immune cell, this guy's got a thing going on. I'm gonna eat you. Nom nom nom. Thanks, bro. I got it. I'm gonna check this fool. What you got in there? Yeah, give me those polymerases. Here's some other ones for you. I don't want those. Is it a virus? I mean, a white blood cell is literally basically like a bacteria, if we're being honest. But then it also performs multiple functions like a virus. So, I'm not sure. I mean, we're probably going to have to target white blood cells or T cells or something, because it's about the size and like how it detects things. Right. Polymerases are proteins. It's true, if I remember correctly. It does say it is a protein over here. Let me just see this real quick. Let me just scan this real quick. They're polymerases. Is that a protein? It's a polymerases. Is a polymerase like a protein? Let's look this up. Polymerase like a protein. It is an enzyme, actually. Huh. We can make an immune cell targeted enzyme. They already do, don't they? Let me see this. Do immune cells target enzymes? Enzymes derive key processes in immunology. Within the innate, for example, neutrophils secrete granules containing various enzymes to create synthesis of antibacterial compounds. Secrete host extracellular to enable cell migration through damaged disease. So revealed. Woo! 2017. Load. Don't you know I'm trying to school some PhDs, bitch? Except I'll continue. Go away. So immune cells secrete the antibody, blah blah blah. Production of antibodies, immune cells. Community affected B cells make the cells able to sustain cell division. Many targets response. Clearing infection in the body or targeting potential target for drug development to block the types of inappropriate or excessive cell behavior that occurs in cancer and autoimmunity. Maybe. How do immune cells target enzymes? Enzymes are immunotherapeutic. First immunology. So protein digestion is in proteins and breakdown is the targets. That's better. And that's excessive. Whether tissue they serve, especially H1. So if they secrete. So we'd be having them target certain enzymes and secrete certain enzymes. That's really all that would be. Cytokines, innate and adaptive immunity. And those are search. Look at this. Proteins. There is a growing list of exceptions. They do not possess enzymatic activities, although there is a growing list of exceptions. Fucking ass. Huh. Good old Google. Good old Google. So what if we just make it secrete a protein, a cytokine or a chemokine that happens to attach to a polymerase? Well, I mean, there's nothing saying they can't attach to a polymerase, right? Can Control V, you fucker. I can't believe I God damn. Two enzymes can attach. What did you have copied? A very long list of proteins. Glycoproteins. Okay, whatever. I'm gonna move off of that. What? Yeah, it's not worth it. We're gonna be going through oh my god, there's 5,000 different fucking stupid things I have to try. This is stupid, no. That's stupid. No, why would I do that? Why would I do that? I mean, I could just take a pill that has the polymerases that I want, or an injection. The immune system's going to attack it. If I want to attack certain permanent cells like neurons, then I use a calcium binding protein. It attaches, it thinks that there's an isotropic cyclin D1 or RB170-130 protein. It attacks it, damages it. It goes, well, there's a flood of this polymerase. And also there's this, what is that? Cell membrane repair material, proteins and enzymes to help the DNA repair itself properly? I just changed my immune system to what that is. Take the pills. And let it repair itself. That's all I have to do. Just add in the polymerase. Yeah, or something. Whatever that protein is. I don't really give a shit. I guess I'm having to go freaking tweet this shit now. So, adding in the polymerase. Polymerasa. The polymerase epsilon and delta variants that are the correct change to the DNA areas that have, that's a better way to put that, have the correct change to the DNA areas needed during the mitosis beat down the immune cells. Now give them with the complexes there to help and support good DNA cell membrane repair. Okay, so and this is where it's like, well, wonderful, but I just want to get the basics there, because it's like we're nearly there. How do you get rid of the old epsilon delta? I know. Oh, we're saying nope. Now we need to know the right thing to do. We brute force it. We got it. It's gonna happen. What are we doing next? So polymers, I mean, they're proteins, right? They're apparently proteins, I think. Right? Did we look that up? Polymerase. Thank you. Polymerase. Are they proteins? Are polymerases? My sleeves. Proteins. Complex multi-protein machines. So, yeah, basically we could do that. They're proteins. Alright, so I have to change this. So adding in attacking the polymers and delta proteins. So by attacking, we're completely redoing it. The polymerases, delta / epsilon, delta epsilon proteins. It's all about the fact that it's just swimming around just everywhere in your blood right now. Oh, thank you. Yeah. It's not impossible to drop it off. Yeah, with a carrier. What? Yeah, I mean, it needs to pass the gut, man, and the fucking, like, liver, if I'm gonna take a pill. I can shield it. It's not saying I can't shield it. It's the immune system. And so I need it to be hidden and then change into the polymerase delta epsilon variant. It needs to be, upon breaking off its shielding, to seem like it's not like that to the immune cell. It's just a carrier. It's a Trojan horse, basically. Trojan virus. How would you do that? That's a good damn question, actually. Look at this. Manash Sastriya. That's what that was. What can proteins... Well, actually, let's just go into this real quick, because this needs to be activated. So MC unwinds the complex, recruits DNA polymerases, initiates. So those DNA polymerases need to be... So recruits, how? So it needs pCNA. Which it's gonna have, but it's not gonna have that much. So the damn cells regenerate. Yeah, the membranes. Brute force it. That's all it is. Needs to cut it. That's the thing. You cut it off when it gets in there to the nucleus. Geminin inflows of the PSCMA binding. Relating to the determination DNA initiation. So it's complexly pursued. Some complex derived from CDC MCM2-7 and it's complex. DNA origins recruits DNA polymerases. Polymerase. There's polymerase. It tells it to start and stop. Can't use that, unfortunately. Yeah, no, because, yeah, right. It's like, ooh, hey, well, break off whatever that is, and also start. Wait, no, I can't. How do I tell you to start? It just did the thing that tells you to be there. You know, it's like, hey, what's this 2 for? We know we added the 1 here. How did this 2 happen? You know, it's kind of what it feels like. It's like, so I brought over this 1, I got rid of the other 1. Where's this 2 coming from? For my toast. It's not quite like that, you're right, but like, you get the picture. Plumbers 2, my total code TBP. To my total code. This is any replication. So it's a transcription factor? I don't know. It's like there's gonna be a shit ton of things. What do you want to use? Because like there's gonna be a lot of stuff that it just ate. Actually, what are immune systems? No, we want it to leave. That's for sure. Yeah. What do cells signal to repair? That's a good question. Cells signal. There'll be more than enough of that around. Tissue repair complex, calcium and extracellular signal related kinase. Can we make a kinase to cut like extracellular signal kinase? Extracellular signal kinase. To cut off it's the outer shell. We only need like a couple little phalanges or 1 or 2. It just says, I'm not what I say I am. I swear, dude. I swear. Look, man, this is what I got. Wiggle, 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 wiggle. What do extracellular signal related kinase disconnect? Cascade essential regulatory activate. I don't want to. Okay, chemical process. ERK chemical process. Yeah. Because that's actually what we need to know. Communicates signal from a receptor of the surface. Ooh, Wikipedia might actually have something. Chain of proteins called receptor, surface cell. Activates cells. On and off, cancer cells. So it just adds to it, so it just goes into a receptor. Anyway, extracellular cells as the rest proteins swap. Flipping on a pathway. Transcription factor. So if it has a receptor that it just breaks the protein off, like, because it's like, I don't need to be attached to you, I got them, because it's got to be doing that in some way to activate pathways. Yeah. So signal starts the pathway to binding and then allows for the protein to swap a GDP molecule for a GTP molecules, flipping the switch. So instead, it just bump it off. So we'd attach it to a RAS protein that would allow for us to swap the GDP, but no longer is it GDP, and we're actually just going to swap that for old polymerase. So let's do this. So by attacking, okay, so after breaking open the cell using our immune systems, our immune cells, we will use a pill with a polymerase delta epsilon, whichever one it needs to be, whichever one it needs to be, with a, what is that called? ERK attached to a polymers, that's a protein that swaps the old one for the new one. For the new genetic change during mitosis, using the calcium binding protein attacks for calcium binding protein attached to the isotropic protein and cyclin D1. Okay, isotropic protein marker, cyclin D1, and it's true to do look a little bit like that. Cyclin D1 and RB107, 130 proteins to break into permanent cells and be able to change their DNA profile during repair with floods of the E2F 1 through, is it 2 or 1? Let me see that again. Yeah, 1 through 5. 5 to start a rebirth of the cell. Let's just go with repair. Yeah. Let's go with repair. let's just delete that. Why? Well, it has to go through division. To be forcing a division to permanent cells, which they don't do that. It'd be a brand new fucking way of doing that. Do they do that? They have all the same cellular structures as we do. They're eukaryote cells too. There's nothing saying they can't. They just don't. There's nothing can get into it. I guess. Yeah, sure. F5 to start division process. Possibly. Alright. Yeah. With a ERK Trojan horse Trojan horse swap for the new DNA synthesis proteins to fix stuff in neurons, nerves, hearts, so on. Of course, needing the necessary. There we go. Necessary mRNA and enzyme complexes. The Trojan horse ERK is so the immune system doesn't attack it until it just doesn't attack it. Yeah, it doesn't. No, it just doesn't attack it. All right. Why wouldn't it? It doesn't see it as it. It's wrapped up in it. So, I think that should do it. That should do it, yeah. Right, we could by using, what is it, lineage markers for our, and was it endothermic is not the word, embryonic endothelial cells. Thank you. Create a immune cell change automatically with Should I spell that right? Oh, lineage. Lineage, not lineage. What are you doing over there? So you don't know when to stop, do you? You gotta hit me for saying lineage when it's spelled lineage. Could you not? Alright. So, cell change automatically to automatically to. So, immune cell change, creating immune cell difference, which does this. And periodically, because it's like it's calcium markers. Yeah, no, and that's the thing. Like the CRISPR-Cas9. So there's we just let's exit out of that. So using CRISPR. Is that how you spell it? How do you spell CRISPR-Cas9? CRISPR. Is that what it is? No, I'm using a Y. Of course. Yeah. CRISPR-Cas9. You could focus on cell targeting through lineage markers for R. And okay, now I have to actually boom. To produce a response like this without a dead bacteria or virus. It's like how, and it's like exactly, that's the problem. It's a DNA changer. It has to have the stored information, which means that it automatically be there. Yeah, if we knew what it was. Do we know what it is? I mean, so those target fucking things, I know, right? Jesus. It's all about so how do immune cells target things? Let's just go with that. How do immune cells target cells? CTLs, kill targets, top of it. I don't care about how they kill things. I want to know how they target things. How do they know what to attack? IgA enables them to recognize the kill targets. Choose one of the antigens is a weakened or live virus and activate immune system memory. We have to go to can immune cells target proteins? Let's just go with that. Binding to target antigen. So proteins on the surface. Cells. So we can get to the proteins. We can get proteins. Does it store that? That's a good question. How do immune systems remember antigens? Let's go with that. So it's just lymphocytes. CD8 memory T cells. I know, like honestly, I'm just kind of bored. Really? Oh yeah, I've far surpassed my fucking stemmed moment. Like, oh, I was stemmed 9 hours ago. Now I'm over it. I'm so over it. Ugh. I don't think the CRISPR-9 is the right call. Nah. Could I go back? Could I exit out of this, you bastard? I have to go. Just stupid delete everything. There we go. Alright. But I have to use the correct antigen isotropic for our regular cells attached to a virus or bacteria. Alright. Hashtag biohacking. No! But nothing. You have to delete a period. Boom! It's done. I'm over this. So over. You haven't ever begun to see the amount of over I've been. I'm super over. I think I've just literally solved like cancer, aging, and I'm tired and cranky and I want to go to bed. Ow! My legs. Gosh. But sitting in an awkward position for fucking long ass fucking shit. Fuck. Ah. Oh, fucking ow, 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 ow. We'll get to crouton later at some other point. Alrighty, folks, that's it.